Tushar, unmute. Tushar, unmute yourself.
Sawan sir, I have started live streaming also and recording also. Okay.
Okay, but I think Tushar is muted. Ask him unmute.
Hello, Tushar.
Tushar, you can start.
Your voice is not coming. You are not audible.
He is muted.
No, not muted, sir.
Tushar?
Maybe he can switch off his video
Hello?
and show the audio.
Tushar?
Yeah, am I audible now? Hello?
Yes, yes. Yes, Tushar.
Yeah, good morning, sir. Good morning. Hello?
Hello, Tushar. Yes, we can hear clearly.
Okay, so we start the event. So on behalf of all the co-organizations who are holding this webinar on this very auspicious day, World Water Day, declared by United Nations 22nd March. And this is joint venture with SOCLEEN, that is Society for Clean Environment, CSIR, Council of Scientific and Industrial Research, Ministry of Science and Technology, Government of India, and the International Association of Hydrologists, along with the National Society for the Friends of Trees. So on behalf of all these organizations, I welcome all. We will have a very fantastic day. We have lots of speakers lined after, and I invite Dr. A.D. Sawant, the President of National Society Friends of Trees, so to brief about this seminar. Over to Dr. Sawant. Thank you.
Dr. Sawant. Sakina, please phone him. He's muted.
Sawan sir.
Unmute.
Yes, sorry. Thank you, Tushar. Dr. Tushar is the Vice President, National Society of Friends of the Trees. And myself, Sawant, Dr. Sawant, President of National Society of Friends of Trees and the SOCLEEN, Society for Clean Environment. Friends, welcome you all. Dr. Firoza Godrej, President Emeritus, she could find time to be with us. So it's a very good thing that Madam has joined here, and we'll have a word of wisdom from her as well, because she's also a keen environmentalist. So I'm sure that all other dignitaries, the office bearers, Dr. Rakesh Kumar, Vice President, SOCLEEN, and OSD at CSIR Delhi, all members of the SOCLEEN, National Society of Friends of the Trees, CSR, and International Association of Hydrogeologists. We're all here to observe a very important day, and that is World Water Day. And the theme of this year's celebrations, observations, the work that demands is the groundwater, making the invisible visible. And that's really mystery. Groundwater is mysterious. None of us can see it. And so rightly, the UN has adopted this theme after its meeting in Rome, that very precious commodity of water. It is a plenty, but it's mysteriously underground. So by all efforts and good technologies, make it visible. And so we thought of having this celebration with great experts in the water and groundwater. They have been doing this great work as a scientist, and they were at the heading the national organizations of the government department, Government of India. Friends, we are so lucky to have them here. So our focus is on the water experts to observe this day, other than anything else. I shall make a very small talk later, because the National Society of Friends of the Trees and the groundwater relationship, we must ensure something talk about it, So it's very important that technologists are here, experts, researchers, and policymakers. When they are introduced, it will be very clear to you all that how great they are. The SOCLEEN is organization. Now it's over 50 years plus. We have had to celebrate Golden Jubilee, but because of pandemic, we couldn't. And it is a organization again started by technologists, most of the scientists across the country, more from the BRS and IITs and institutions and universities, and eminent persons like Dr. R.C. Wala, Dr. P.J. Devras, Dr. D.J. Jasawala, who was oncologist, Dr. Sarnathan, Dr. Mishra, and experts like still very active with us, T.N. Mahadevan and Vidya. And Rakesh Kumar himself is associated with, So we thought of, see, groundwater, making it visible, it is, all have to put their hands together. And that's what the call by UN, Everybody has to work together to make groundwater invisible to visible, So naturally, the Friends of Trees was the best partner to be associated with, in addition to CSIR, Scientific and Industrial Research Institute of this country. We have 39 research laboratories across the country, and they have been doing pioneering work in research and research funding and all that. We're so happy that to have them also with us. There are various bodies working in the water sector, including the World Water Council and hydrogeological associations in plenty across the world, of which the International Association of Hydrogeologists is joining with us. I must tell the Friends of Trees also has done a pioneering work in these areas and plants which are very important role of entire climate, and climate change does affect the groundwater, and the restorations and conservations of trees and the forest, and all these are very important in sustainable maintenance of the groundwater, So, Friends of the Trees were established way back 62 years, and none other than the stalwarts like then Chief Minister V.P. Naik, then Mr. Bhabha and S.P. Godrej, Joseph John, Mrilani Sarabhi, Rusi Modi, all the stalwarts, and then we're lucky to have Dr. Firoza Godrej from the illustrious house of Godrej to head us for 15 years as the president, and now she's president emeritus. And many others like, Dr. Kothari and Naik, and they all contributed a lot to bring the National Society of Friends of this to this status. So, friends, without taking much of your time, I welcome all of you, and it's very important to welcome our expert speakers, and we could see your Dr. Sivendra Rai, the eminent expert who worked also in Maharashtra for explorations of the underground water resources. He shall be introduced formally. He is speaking from Orlando. In fact, that will be his first lecture. We shall be also having Mahendra Mehta from Jaipur. Right now he's in Goa holidaying with his family, but preferred to give us this morning to speak on. We shall be also having Dr. Ratan Jain, RC Jain, advisor to Gujarat and the Maharashtra and so on. He was also an authority at the Government of India, was heading the Water Board, Central Groundwater Board, Water Authority, and so on, We shall be also having Shakil Ahmad, professor, he's honorary professor at Hyderabad Institute. He's a professor emeritus at CSIR and secretary ASEAN associations of the UNESCO of the groundwater and all. We shall be also having Dr. Rakesh Kumar. He shall be also speaking. He's part of the SOCLEEN. And we shall also have Professor Sina, who is a Vice Chancellor at the University in Mumbai, Chhatrapati Shivaji Maharaj University. It's a private university. He was my colleague at the University of Rajasthan. Again, a very eminent geologist, and he's heading that association of Hydrogeologist India chapter, We shall also have the T.N. Mahadevan, the founder member of SOCLEEN, and he shall be talking more about the SOCLEEN and the theme of this. So without taking much of your time, I welcome you all for this very great event where we have to think and brainstorming on for water security for all. And as rightly said, all have to join the hands to make this water available. Visible means available. So thank you very much for joining this, and all the participants, I'm told, are very large in number. Over 160 participants have registered. I'm sure they will slowly trickle into this and take the benefit of this all talks of the experts. Thank you very much, Dr. Tushar. Thank you. Thank you all. Tushar, unmute yourself. I invite Dr. T.N. Mahadevan to say a brief about the Society for Clean Environment. SOCLEEN we call it. It has a very distinguished, indelible mark made into the minds of the people who, in environmental awareness. So without wasting much of the time, I invite Dr. T.N. Mahadevan to say a few things about the SOCLEEN and the theme. Dr. Mahadevan? Tushar, Dr. Mahadevan?
Seems he is not yet logged in.
He is not able to connect. Hello, Dr. Mahadevan? Okay, then let's proceed further, and we invite Dr. Firoza Godrej to have some introductory and welcome remark about this thing. Dr. Unmute, Madam, unmute yourself.
It's a real pleasure to be here with all of you this morning. I am not a scientist, as you all know, and FOT, I'm an art historian, and my PhD is connected with art history. But from the last 50, 60, I don't want to give my age away, but for the last 5 decades, 6 decades, I have been passionate about the environment. We were raised that way as children, and as indeed many of you must have been. It's in all our collective DNA. And I speak to you very generally in this introductory speech. I have just looking forward to all the scientific data you have to offer. And on behalf of MT, on behalf of SOCLEEN, Society of Clean Environment, who have invited us to be co-hosts this evening very graciously, this morning rather, Friends of Trees, along with the Council of Scientific and Industrial Research and the International Association of Hydrogeologists. It's all very prestigious, all very good and sound science-based organizations. I extend my warm welcome and join Dr. Sawant in welcoming all our speakers who he has named earlier, and especially Dr. T.N. Mahadevan, Dr. Sawant's counterpart, who regretfully is not here right now, but I'm sure during the course of this few minutes, he will be able to join us. And so many scientists and speakers who have joined us nationally and internationally at unearthly hours of the time, based in the US, based in Europe. So thank you so much for rising to this invitation and being with us here today. It's a real pleasure and a great privilege, let me assure you. Just before we started, we bring out a bulletin called Vayner Shobha, discussing it, and we will be requesting you for a small paragraph or a synopsis of your talk with maybe 1 or 2 illustrations and we'll be delighted to cover these proceedings in Vanashobha. Dr. Sawant, who's the president this year, has very graciously agreed that it can be included in the Vanashobha. So thank you all very much, and thank you, Dr. Sawant. Just a few words and a few thoughts on what we're going to be discussing. Groundwater making the invisible visible. Groundwater is invisible, but its impact is visible everywhere. Out of sight, under our feet, groundwater is a hidden treasure that enriches our lives. Most of the liquid fresh water in the world is groundwater. As climate change gets worse, groundwater will become more and more critical. This year's theme, groundwater, draws attention to the hidden water resource that has always been critically important but not fully recognized in our sustainable development policy making. Water is at the core of sustainable development and is critical for socioeconomic development, healthy ecosystems, and every child knows, for human survival itself. It is vital for reducing the global burden of disease and improving the health, welfare, and productivity of all populations around the world. Water is also the heart of adaptation to climate change, serving as the crucial link between climate system, human society, and the environment that we live in. Without proper water governance, there will be increased competition for water between sectors and an escalation of water crises of various kinds, triggering emergencies in a range of water-dependent sectors. The physical world of water is closely bound up with the socio-political world, with water often a key factor in managing risks such as famine, epidemics, inequalities, and last but not the least, political instability. Water is complex because it is linked to almost everything in the world, but complexity should not hinder understanding. Water is a precondition of human existence and for the sustainability of the planet. As per Niti Aayog's report, India is suffering from the worst water crisis in its history. I've just jotted down points because I know the scholars on the panel and those who are listening in and in the Q&A, these points will come up. So it's just points. I've jotted down 11 points, which I'll briefly and quickly read out to you due to paucity of time. Point number one, as many as 1 billion people live in areas of physical water scarcity. Second point, 0.2 million people die every year due to inadequate access to water safety, or drinking safe water, I should say. 3, 6% of GDP will be lost by 2050 due to the water crisis. Fourth, 40% of the population will have no access to drinking water by 2030. That's just around the corner in this end of this decade. Point 5, 2030, our country's water demand is projected to be twice the available supply, implying severe water scarcity for hundreds of millions of people. Point number 6, 70% of our water is already contaminated. 7, India accounts for almost 1/4 of the total groundwater extracted globally, more than that of China and USA combined. But what are we doing to our groundwater and our groundwater table? Are we not thinking or projecting ahead what damage we're causing over here? Point number 8, India also uses the largest amount of groundwater, these 2 points are linked, 24% of the global total. Point number 9, India's rate of 2010, in 1 decade, we consumed 23, depleted our resources by India is the third largest. But it's a fact. These are Niti Aayog's figures. Sorry, somebody has put me off the screen, but as long as you can hear me, that's fine. India is currently ranked 120 among 122 countries in the Water Quality Index. It's very, very sad. I don't know why this has happened, but it's happened. I will just continue and round up now. In rural areas, the government standard to supply 55 liters per capita per day does not take into account that a large number of rural households own livestock and need water for their drinking and washing needs. Moreover, in the absence of household level piped water supply and metering, it is difficult to monitor the quality of the water received by each household. This in turn makes it challenging to estimate the per capita needs of rural households. Good part is that Har Ghar Jal. What is that? Water to every household. Okay, thank you, host. Is a scheme initiated by the Government of India in 2019, Har Ghar Jal, water to every household, with the aim to provide tap water to every rural household by 2024. Since its inception, the scheme has significantly improved household cleanup, tap water availability in India. As droughts become frequent, they not only create severe problems for a rural population dependent on surface water for daily and agriculture use, but availability of water for livestock is severely affected as well. I really would like to thank my small team at Godrej, Tejashree Joshi, Hemant Karkanis, and Amar Deshpande for brainstorming with me before we began the session last week, because I really wanted to understand what we're going to be deliberating on today. So thank you, team at Godrej. I greatly appreciate your inputs as well. And from my colleagues at FOT, we need to work together to sustainably manage this precious resource. Groundwater may be out of sight, but it mustn't be out of our mind. And congratulations to all the teams, all the collaborators today, and congratulations, Dr. Sawant, for thinking of this and bringing it to the notice of all the students who have joined us here today. And it is for their benefit, it is for their future that we hold programs like this. So I wish you a very, very informative and creative and innovative deliberation today. And thank you for inviting me to say these few words. So Tushar, Dr. Sawant, over to you. And thank you all the speakers for being with us today. And we're looking forward to listening to your papers. Thank you.
Thank you, madam. Because of poor bandwidth, you were not visible, but your voice was very much visible or audible rather. Just like the mysterious groundwater. The bandwidth was low, so you could not be seen earlier. Now we can see you, but we heard you very well and you highlighted very, very important points. Thank you very much for excellent data that you have given to us. I can see Dr. Mahadevan now. Dr. Mahadevan, you are there. It's your turn to have a few words, please, Dr. Mahadevan. Unmute yourself, Dr. Mahadevan. You have to unmute, please. No. Dr. Mahadevan, please unmute. I don't know what is the problem. He's talking, but...
Sir, you have to unmute yourself. Dr. Mahadevan, you have to unmute. Yeah.
Okay.
Yes, now it is okay.
Okay, please. Yeah, coming back on video. 1 minute. Yes. Are you all right? Are you able to listen to me?
Yes, sir, very much loud and clear.
Yeah. Yes, good morning, Dr. Sawant and all other participants. I'm so happy all the time. Someone gives me the topic to talk about SOCLEEN. Today, I may not be able to talk about SOCLEEN much, except for so few words. SOCLEEN was started in 1969 to address basically the environmental issues of air, water, noise, and all other aspects of the environment. But then during this time, we also looked into the groundwater pollution in one of our surveys in Chembur. Because one of the paint companies, there were a lot of complaints around that there was a hamlet of 100 houses, and they were getting their water contaminated. This provided us an insight into the seepage of pollutants into the groundwater. There, the journey of SOCLEEN started in terms of the groundwater leachability aspects. But then we were more concerned about the unconfined groundwater rather than the confined groundwater, because confined groundwater, as all of you know, you're all experts, it is just below deep and below the geological macadam, where the velocity of the water will be very small, but the expanse will be very long. But this unconfined aquifer was the one which was becoming the source for input into their well water, which they were using for many purposes. So this is how the journey of SOCLEEN started in groundwater. Then we had a lot of well waters in that area. Chembur got cover area analyzed, but most of them were unconfined. But yes, we touched the confined reservoirs or confined groundwater potential through our survey in the Tanabellapur belt. Because, the chances of mercury getting into the unconfined waters was a question mark, and nobody had touched that problem. I tried my best, and we could identify 3 borewells dug by some industry to supplement their water. This gave us a feeling that, is it connected only with the urban environment, or is it also in the rural environment? And I can guarantee to tell you that it is more related to the urban environment. Unfortunately, places like Mumbai, we don't have the problem of water much, so the confined reservoirs of groundwater is not tapped very much, and the seepage of pollutants into that is comparatively very less. And then I'm very happy that this is happening. At the same time, I had a tough job when I was asked for a solution for storing some toxic waste. It was already cemented, which was already fixed in the cement. And they wanted to store it underground. And that's the time, that was by my alma mater, that was the time I really went into the aspect of the confined reservoirs also. And I'm very happy to share with you that, yes, some ingress, even into the confined macadam of groundwater could be seen, but it was not very much. It was about millions of the concentration that one could say that it is potable or unpotable. So this is where my involvement with groundwater came up. But to be very honest, if you visit cities like Chennai, or maybe North India, I don't know much about it, the ingress of salt water due to pressure difference is always there and brackish water comes up. But here the learning should be that, we should maximum see that we are able to harness the surface water or the rainwater that we are, because even in the groundwater, when you are talking of, maybe geologically it might have been formed, but the surface water is the main potential for it to really seep into, do fractures into the geological system into over millions of years. So that should not be forgotten by our people all around. And I appeal to all of us that we try our best to see that the surface water potential is improved so that we don't have to tap the groundwater too much, except when we have natural calamities like famine. But take it from me, always the velocity of surface water is much more faster, because as depletion comes out, it moves faster. And there is a tendency for it to really seep through into nearest reservoir or nearest water body. Whereas in groundwater, it is of the order of about a centimeter of a millimeter in a day, I would put it. This is what I have learned from my geological friends from various countries and also from various experts in India. So this is my thought of what should be the groundwater and the confined and the unconfined groundwater we are talking of. And I hope, the deliberations today will throw better light on all the subjects. Thank you, Savan. Thank you, Savan.
Thank you, Dr. Mahadevan. Tushar, Dr. Tushar Desai. Well, he is muted.
Hello.
I am supposed to give a very short talk on the title. I would say
Yes,
that just the relevance of today's topic, and that too also with bridge it with the friends of the trees. Friends, you know that the trees are too important, and we always say that do the plantations of trees and the forest cover 33% minimum and all that. And we have the belief, facts and figures also, and so misconceptions also about the trees and the water and the groundwater. Some of those mysteries or concepts or misconceptions I would like to speak upon in the topic that I shall be covering in just 10 to 15 minutes. The trees and groundwater interdependence, See this celebration of World Water Day. Every year there is a great thoughts coming into various organization members of this association, and particularly this time that was International Groundwater Resource Assessment Commission. They put forth their views saying that groundwater is too important, and they put forth the figures and their assessment work convincing UN to accept this thing when they say the drinking water comes, 50% of the drinking water comes from the groundwater, and 40% comes the irrigation that is also coming from groundwater, and 1/3 of the groundwater is used by the industries. So when this is a situation of groundwater, but it is also mysterious. We do not know, and various efforts we make in search of the groundwater, which is mostly not in our hand because that depends on the soil structures, the fractures and the pores, and so many other factors and technical aspects of that the experts shall be talking about it. But when we know this is the situation that how important is the groundwater for all the purposes that I did mention, it shows that it sustains the ecosystem, all of whether the trees or the entire ecosystem or biodiversity. It maintains the base flow of the rivers. If there is no groundwater, I don't think we can have the perennial rivers, and even on after onset and offset of the monsoons also, you do find rivers are flowing, even rivulets are flowing, coming even from the hillocks, mountains also. And the groundwater also does a many important role, and that it prevents land subsidence, it's very important. And the more important that the country like ours, where a lot of sea coast is available, and the intrusion of the seawater to the groundwater is also prevented by the groundwater, and that's how it maintains its own existence, not allowing the seawater to intrude into the lands. And so these groundwater bodies, freshwater bodies are maintained, So it's also important part of the climate change and adaptation process of the climate. It provides solutions for the people, and this is most important, commonly found in the rural area. The people who do not have access to the safe drinking water, for them the access is groundwater in the most non-conventional ways. They have their own mechanisms, not only the well and the bore well, but even a small ponds they make. It is fairly good enough, if not potable. That water I can say is raw water. People have been, most of the people in the rural area, they take that water. So there are no treatment facilities like we Mumbai city get potable water, safe drinking water after so much of the, or rather huge treatment that it is given to that, and so you get pathogen free or toxins or toxic elements free and potable water. So this is how it plays important role. So therefore, it is the call given that this invisible groundwater is made to be out of sight. Let us see that and put spotlight on this. And at the same time, as Dr. Mahadevan also has said, that how groundwater gets contaminated. So in enhancing that availability, the awareness also is very important, and the care of the groundwater is very important, because we get so many examples, contaminations of groundwater because of seepage or industrial pollutions, or even the backwater pressures from the areas where a lot of effluents have been dumped. Now, friends, in 5 minutes, I shall be just talking about the role of trees and interconnections with the groundwater. If you believe that lot of forests can hold lot of groundwater, no, it's not true. And a denuded land and the grass and the grasslands can harvest good groundwater. Yes, it is true. But then it is again a forest, and tropical forest is the most important for sustainable environment or the minimum availability of water. So that trees, they're the interceptors for the monsoon or the rainfalls. They'll be catching the falling rains, and when that is happening, they naturally, water is a must for the life, and so the trees. And the process of evapotranspiration happens. And this evapotranspiration is more important to bring the rain to us. And so that is the role that basically prima facie they do it. And so lots of research is happening, whether trees will help in groundwater, enhancing the monsoon, or holding the groundwater table, or raising it, or whatever it is. So these tropical forest research institutions have been doing a lot of work on that, and they have done many experiments. Even our Indian Institute of Science, Bangalore, have been doing a lot of work in urban areas, the relationship between groundwater and that of vegetations. So both the monsoons and summer, in both the time, these trees, when they take so much water, absorption, retentions, holding into that root system, it will minimize the risk of, I would say, the risk of risk related to security of water. In the forest and the rural areas, or the tribal zones, many of these plants, they are used as a source of drinking water. The costus that we talk about, it's a wild plant, and ficus some species also. In fact, people can extract out water from those full of minerals, and this costs us this called in Marathi called peva. So just cut the twig of that costus and they just chew it and get water from that, you know. So this is how when the scarcity of this water, then this comes into, and it also prevents the flood. It is a belief that, and it is a true proven fact that they hold a lot of water, you know, whether it is just a plain flood plains or when the vegetation's there on the trees, they hold a lot of water, and so reduce the risk of flood. So existence of the forests and the trees is very important, but at the same time it has a very complex views also. Geologists, the hydrogeologists, they were talking to us today. They in fact deplete the source of the water, you know, because they take a lot of water, and when they take a lot of water, naturally there is a shortage, and we came to know that there are many trees like eucalyptus. When it came from Australia to India, this eucalyptus tree takes a lot of groundwater, you know, and therefore it is difficult to engross doing plantations and then deplete the water table. It has been proved that the trees like some trees, they improve the groundwater, you know, like neem, ashok, tamarind, and jamun. These are the trees proved to be improving the water table, whereas the other side, I said that eucalyptus, they will take away the water from the groundwater, you know, source of groundwater. And so this is a win-win situation. And in the process of photosynthesis itself, you know, the two molecules of carbon dioxide and 12 molecules of water, from where that comes to? The trees, the storehouse for the water themselves, and in presence of sunlight, they'll synthesize glucose, and then they release up to the glucose molecules, very essential for us in the food chain. They release 6 molecules of carbon dioxide and 6 molecules of water. So they take 12 and give back us 6. So the photosynthesis process, which is a technically chemical reactions, very important. The electron capture process, it is in fact, I will not go into that, but releasing the oxygen as a byproduct, like, you know, so it is important for us tapping the oxygen from the atmosphere, and how it is important in the pandemic situations that we have learned natural synthesis. In fact, 50% of this oxygen comes from this process and rest from the oceans, you know. And so therefore the trees will playing very important role. They also enhance the soil filtrations, and under suitable conditions, they will improve the groundwater. Now there are various experiments done. They can tell us the trees with enormous root systems or roots, they will absorb the more of water and store it in the roots and increasing amount of water in the ground. So this is how the trees will be helping to improve the groundwater situation beneath the soil, you know, and they will use it for itself, use for a microbe, will also be used for so many activities, releasing the minerals, and without water and control conditions in the pH, no minerals can be uptaken by the plants. So the self-sustaining role that should be playing. So the existence of water in the ground and root zone system is very, very important. Otherwise, you can't serve the crop systems, you know. They'll also allow more water to enter in and raise the groundwater in order to the process of the percolations, you know. So the trees do groundwater conservations. They allow continuous percolations also, the excess water, and that also the source of the uh, culminations into the water streams in a deep dense forest, you know. And therefore this system of whether you should have the tropical forest to protect the groundwater hydrology, no, but the kind of the select system of the plantation have to be planned. So therefore, it is very important to do plant plantations, you know. The moderate density, forest density will only help in groundwater storage, but the high density plantation It's good for environment and climate sustainable climate things, but as far the water level is concerned, these dense forests has been experimentally proved uh, that more the away from the tree you go, you will find that this groundwater storing is better, but rather percolation part is concerned. More near the tree, you can have a good percolation of water. So it's a win-win situation. So to have it or not to have it is different situation, but you need to have a definite action plan for making the groundwater storage better, and therefore selection of the plantations, the kind of density that you require to is also required to be a plan. It is very interesting to know the cropland, the grasslands, in fact, are the best places for the recharging the groundwater. Where the trees and forests are there, it should not be chosen as the recharge site. They themselves will take up the water from monsoon and will maintain the water level, moistures and the biodiversity, everything. But when you talk of explorations of the groundwater, it is more of the land which is semi-arid or the crops or grassland that the best one proved to be for a good groundwater recharge if you want to do, whether it is by natural system or mechanically if you want to do that. Therefore, friends, various experiments have been done in this area. It has been found that the forest density, very high density, does not mean there is a lot of groundwater. It is rather reverse of that. And if you do not have the trees, and if you think that percolation of the water will go on, because what happens when the rainfall is there, saturations of the top layer, then second layer, when it happens, then the runoff starts. So this saturation will be there with the pores of the soils, more of that surface available. So they will start percolating water into the ground. So as far as the groundwater recharge is there, these lands are preferred than the deep dense forest. They are also necessary, but then as far as the hydrologically you are seeing that you may not find good hydrosphere there under the beneath the deep forest, because trees have been taking away the water on and off, I mean, continuously. And so therefore, it is not the area to be dependent upon the groundwaters. So the last point is that the Institute of Science, Bangalore Indian Institute of Science, they had carried various experiments, and they have proved that the concrete can reduce the groundwater table, and that is all of us must understand. City like Mumbai, if you go for a groundwater table, it must have gone heavily down because there is no recharging facility or scope for recharging, because a lot of concretization, not only the complexes, residential buildings, but also the streets also. And so, though the vegetations improve the groundwater table, you have to select the vegetation that will allow percolations and enrich the water table, and not any kind of the trees that you go in for that, because this will hold the water, the top layer, and then only it can allow the percolations. And therefore, it is suggested that only native species which have the good and useful root system, fibrous root system rather than the taproot system, than most of these trees that we import from other countries. So they suggest go for the native trees or native crops or native vegetation. So it makes a kind of shrubbery on the semi-arid lands, which is the best source for tapping the rainwater, and they themselves will be harvesting, improve the groundwater levels. So these are the issues which are bothering us. You see the floods in Mumbai, urbanizations, the complexes, road, residential buildings. They all have removed the vegetation, so there is nothing to hold the water. Everything is not top layer, not second layer. Everything it runs off into the water bodies, and so city like Mumbai, you have Mithi and all that. It is all collection through entire these hundreds of square kilometers of the Mumbai area, at least the areas around these rivers, water bodies. They receive a lot of water, and then that accumulation cannot happen in the ground. So that results into the flood. And therefore, the concepts that trees will increase the groundwater availability, or rather trees will consume more of the water, do evapotranspirations also. So this is the win-win situation. So the relationship of the trees and the groundwater is the situation, I would say, positive and negative also. So it is that we, the environmentalists or the experts in the forest and the groundwater, has to design. So it's not only architecture designs required for urbanization. You'll have architecture designs for the kind of vegetation you want to create, or kind of vegetations or the crop you want to take. It's always talked about it, but the kind of the plantation that we required to do to so that it supports the groundwater. And once it is sufficient groundwater, aquifers and all that, now the question remains then how to make it visible, this mysterious groundwater. And so then comes the technology. So friends, today's webinar is more focused on the technologies which can help to understand where is this water, how to look for this water. Many times our search for the water results into the vein. 10 times 10 places you try to have the bore well and the water doesn't strike there. There are so many conventional methods, orthodox method, unorthodox method. They come in, play their role in a great extent, to tap this water, So the technology and the conventional ways, I don't know what it is all, but these experts shall tell us that which way you should make an approach to this groundwater to make it visible. And once it is visible, I think people talk of world war for water and all that. Keep aside all those things, but as the data says that 50% of the groundwater is ultimately available for the drinking and rest for irrigations and industry and other uses, So friends, a very important topic that we shall be dealing today. So I think I have taken about 5 minutes more. And so we should now proceed for the next concept lectures by the experts on the subject of the World Environment Day, World Water Day, making groundwater visible from invisible to. So thank you very much. Thank you all. Dr. Tushar, please take over.
Dr. Sawan.
Thank you. Thank you. Thank you, doctor. Yes. Thank you, doctor. Yeah.
Yeah, you are.
Yeah. Thank you, doctor. It was really eye-opener, the relationship between. Hello. Yeah. So, in fact, I will apologize, doctor, for not introducing you. It was connection disconnectivity. The person you heard him is a very authority. He's not only academician but administrator, the leader by himself. He's got a very big biodata. I'll just brief you about this. Dr. A.D. Sawan, he's been the professor of chemistry and environmental science in the Institute of Science, Mumbai. He was joint director of higher education, pro vice chancellor with Mumbai University. He was even vice chancellor with the University of Rajasthan. Currently, he is the president of Society of that is SOCLEEN, National Society of Friends of Trees. He is member of World Water Council, trustee director West Energy Council. He has guided 26 PhD students, 150 publications, several reports on environmental issues. He has worked extremely on toxic waste metals and handled several environmental issues. Input.
This we skipped.
Hello.
For the next lecture now. Go for the next lecture.
So I invite. I invite Dr. Deepa Verma to introduce the next speaker, who is going to talk about the making invisible groundwater resources visible for sustainable development. Professor Dr. Yasendra Rai, who is from International Association of Hydrogeologists. Today he is speaking all the way from USA. So Dr. Deepa Verma, over to you. Thank you.
Thank you so much, Tushar sir. I hope I'm audible, and due to poor bandwidth, I have kept my video off. So apologies to all the stalwarts here in the session. It's really an honorable thing for me to introduce our speaker, Dr. S.N. Rai. If you search Dr. S.N. Rai online, you will probably come across a 20-page biodata with all his work mentioned. I'm sure that is also something which was made some time ago. So just talking about him in brief, Dr. S.N. Rai is an ex-vice president of International Association of Hydrogeologists. He is also an ex-president of Indian National Committee of IAH. He's an ex-honorary visiting fellow of IIT Roorkee. So if you visit IIT Roorkee's webpage, you will definitely find his detailed work online. He is an ex-chief scientist of CSIR, National Geophysical Research Institute, Hyderabad. He has to his credit more than 67 plus papers. He has written more than 22 chapters in books. He has been invited to deliver his expert lectures more than 30 plus sessions. He has presented his papers in more than 75 conferences. His technical expertise, everything is mind-boggling. He has to his credit a patent as well. So if I keep on talking about Dr. S.N. Rai, I'm sure the next 20 minutes will be taken up definitely by me. And we are here to listen to the expert session by Dr. S.N. Rai. He is going to deliver a talk on making invisible groundwater resources visible for sustainable development and management, case studies from hard rock terrains. A very warm welcome to Dr. S.N. Rai and a very good morning to you as well, because you've been joining in midnight from Orlando. So thank you so much, sir, for your courtesy. Thank you so much. Over to you, sir.
Thank you, madam, for your kind introduction. Good morning to Dr. Samant and all the invited speakers and participants. It's my pleasure to attend this meeting, and whatever the work I have carried out, especially I have carried out work in the Vidarbha and Marathwada regions, where most cases of suicides are reported every year. So my passion was to understand what is the reason why such things happen only in Vidarbha and Marathwada region. So I'm going to present some of my work, brief introduction, and then I will take cases from the Vidarbha, Marathwada, as well as the Konkan regions, and also some area in and around Hyderabad granite terrains. So let us start my first slides. So as Madam mentioned that I'm going to talk about making invisible groundwater resources visible for sustainable development and management, case study from hard rock regions. And by profession, I am the geophysicist. And you know, geophysical methods are used to make individual resources visible from the surface measurements. And one of the method is the restrictive methods. So my talk will be structured in 3 parts. The aquifer mapping, that is making the individual groundwater resources visible. That is nothing but the aquifer mapping. Then it will be followed by the after mapping, how sustainable development should take place, and management to ensure the safe and secure water supply. So in total, only aquifer mapping is not enough to serve the society unless and until it is coupled with the sustainable development and management to ensure the safe and secure water supply. Many institutes are involved in aquifer mapping, but their results are not being translated into the development. So that's why we are very lagging behind the use of the groundwater, though the mapping is going on by many organizations. So now I will go to the technical part. You see why I have chosen the this hard rock area. In the map, except this yellow and pink, all the area, 2/3 area of the India is covered with the hard rock. And in hard rock, the aquifer system is very complex nature. their spatial extent is very small, and they are found in a geological structure rather than except in Deccan Trap area, which is marked by the green. So this is a Deccan Trap area has a different feature than other hard rock area. So the purpose is to locate the groundwater resources in a limited, which is having a limited spatial extent as well as the structure. So now for the case studies, I have taken a Chandrabhaga River Basin. It is very close to Nagpur districts, and it is there orange orchids are found, which they were producing large of this orange. But now, because of the lack of water, these orchids are disappearing. Then I heard sometimes that groundwater was transported by train to the Latur district. It was very surprised and very shameful for the geophysicist. So I selected Kavarja basins, which is 25 kilometers away from your Latur districts. Then I went to Chiplun Taluk, and then my own institute, they were suffering from water supply scarcity, and my sister labs, IICT and CCMB. So on the request of the director of those institutes, I carried out, and I provided the water to meet the demand of the water supply in this institute. So one by one, I will take up the Chandrabhaga Basin. You see, this is a map of the Maharashtra. So Nagpur is here, and Latur is here. So my area in Latur is the eastern fringe of the Deccan Trap. And Latur, it is some part of the Osmana districts, and then Latur district. And then I have taken one studies. Here, it was not the purpose of the groundwater exploration, but the purpose was the delineation of the geothermal water to harness the geothermal energy, and then remaining groundwater can be used. So you need some guidelines to proceed further surface. So Mr. Mehta, in his Central Groundwater Report published in 1989, he has given a stratigraphy for that region. So the top region is unconsolidated sediments. Then it is followed by the Deccan Trap, and in between the two flows, there are the sedimentary formation, which are called the sedimentary intertrapian. And this lava also, they are divided into two parts. One is the vesicular lava flow, and another the massive. So, and then it is followed by the Gondwana formation, which is mostly consolidated shale, sand, and sandstone. So in this area, my target is the weathered formation, which is the source of water in the dug wells. Then in the below this one, we are targeting, our target is the vesicular layer, which holds sufficient groundwater. And in between the two lava flows, there are the sedimentary intertrapians. So they are also source of water. And if you go below, then sandstone. And in Kavarja Basin, the thickness of the trap is ranging between 40 meters to 80 meters. Below is all the limit of it. And I have restricted, my view is that 100 meters is enough to do the exploration. Beyond 100 meters in hard rock area, it is very difficult to percolate down the water. So this is so I have used these guidelines to interpret the geological sections. And this is the situation. This is one example of the dug wells, which were earlier the main source of the groundwater. So top is the weathered formation, and you see this is the fracture through which water comes, and then is the massive basalt. And these fractures, these dug wells gets water only if this fracture is connected to any stream nearby the stream. Otherwise, you will not get any water. So there is also a very chance that people have spent more than 1 lakh rupees and on a dug well and without getting any water. So we will find, my purpose is to find out these fractures also. and weather, and in massive basalt, these fractures are found. So we are using electrical methods. It's a very simple method. So we send the current from the two poles AB, and we measure the this potential difference between the two points CD. So from this delta V and delta V is known and I is known, and then spacing between the current electrode is known, and A is the spacing between the this potential electrode. So we measure the this is called apparent resistivity, because on the surface whatever the resistivity we are measuring, it is the combined resistivity of the all the layers. So our only measured value is apparent resistivity. From apparent resistivity, invert, mathematically invert to get the true resistivity of each layer and thickness. And each layer is assigned with some resistivity value. And based on those resistivity value, we are identify that which layer is containing water and which is devoid of the water. So this is the Submerger. It was developed sometime in 1921. And then it's a, and another is the Vayner configuration. Same thing, but a different formula because of the geometrical configuration. Formula is the different. But here also we are measuring the apparent resistivity. Delta V is the potential difference between the two potential electrodes, and I is the current which is supplied this one. So now earlier we were using only 4 electrodes and measured, so getting only 1 point resistivity variation. So that is one model. But now recently, since last 15-20 years, a electrical resistivity tomography system has come. So in this system, what we are doing, there will be several electrodes. Here I am showing the 64 electrodes, and these electrodes will be connected to the resistivity meter, and there will be a switching units, and then all the data will be collected. Every measurements will be controlled by the software, which is uploaded into the laptop. I will go quickly because and how the measurement is done. First, there is a spacing between constant spacing between two electrodes, consecutive electrodes. So in the first step, let us suppose we are going to make first step measurements with a particular spacing A. So this automatically this apparent resistivity will be measured up to this depth for the layer of this depth for A spacing covering this one. Then spacing will be increased. It will be made 2A. Then the depth of penetration will be deeper. Then spacing will be made 3 times, and like that we can measure the apparent resistivity value for deeper and deeper layer. So from those values, we will invert those values and get the resistivity parameters. So this is the map of the Chandrabhaga Basin. This is the Nagpur Katol River, and it is here is this side is the Bajargaon forest, and these are the Satpura regions. So there, and this is the Tawarja River. So this basin is also divided into 2 parts. This side is having one, all the drains are connected to the this Chandrabhaga River, and here these waters continuously coming from through these drains, and they are joining near Bhogli. There is a place, and they form one single river that is called Saptadhara River, and again it joins this Tawarja Basin, and then here it goes and meet the Kanan River. So that is the definition of the basin, that from all sides the water comes into the river, and there will be only exit point. So this is the exit point. So blue lines is only showing the location where we have carried out the vertical electrical sounding for 1D model, and the orange points, they are where we have carried out the electrical resistivity tomography, which gives the 2D resistivity model. So I am going to present the results of the 2D, which is very easy to understand. So total we have covered, this area is almost 500 square kilometer area. And we have 103 sites we have made the measurements. And again, as I told you that we are getting different layers and of different thickness, and each layer is having assigned with a different restrictive value. For example, the alluvial and topsoils, it will have a restrictive value of 5 to 10 ohm meters. Then weathered and fracture and vesicular basalt, which is the main source of groundwater, their restrictive value will be 20 to 45 meters. Then moderately weathered fracture basalt, where the water level content will be very less, so it will have a 40 to 70, like that. So the formation which is shown in the red color is our target formation for the groundwater reserves. So one example I am showing you, this is the restrictive model obtained from the electrical restrictive tomography. So here bottom is the index, color index is showing the different range of the restrictive value. So you see this top is a basalt, weathered basalt and soil, and this yellow and this one is the restrictive value more than 300. So these are the basalt layers. And then here is the your low restrictive value. So these are the fracture, sorry. This is the fractures, and this is the clay part that is called the, in geological term, called the bowl bed. So bowl bed are the clay. The clay have a lot of water, but it does not release the water. But fractures, so then after that, we this is the model. Based on this model, we drilled the borehole. So then we were, because of the limited fund, I drilled one borehole. But after seeing the results, the neighbor farmers, he drilled on his own borehole. And both were working, since it is a place, this area in Raulgaon. And outcome is here. This lady is the owner of the land, Bimala. And we drilled, and first she was hesitating to allow us to do the survey. She was thinking that we are from government organization, and by making a measurements, we will grab the land. But we convinced his son. He is working in some cotton mill. His son. So reluctantly, he agreed. So we conducted the survey, because people were not having any faith in the science, because scientists have never reached to the common people. Scientists, people think that scientists are a very high profile positions. They only sit in the AC room and they do nothing for the masses. So that's why it was very difficult for us to convince a person 3-4 times to do this free cost of survey. And then after 1 year, these reporters, they came to see our progress. So behind this one, where there was no any crops earlier, he is the owner of 5-acre land. And this you see the wheat crops. And this is Snehalata Srivastava, is a Times of India reporter. He is Hitwada Dheeraj, and he is India, some Hindi newsletter. And they published the this article. And so another very interesting story is that it's a Rajkumar, owner is a Rajkumar. This fellow spent, I think, I don't know, 1.5 lakh rupees somewhere. This is the your topsoil, and this is all the massive basalt, and these are the fracture. It's a source of water fracture. Yeah. So he spent more than 1.5 lakh rupees without any success. So on the way we saw, and that fellow was sitting, putting his head on the hand. So we offered him, can we help you? Then he was reluctant. He said that what help you people? Then he said, you give us a chance. So we surveyed his field, and you see such a huge water body is there, and at 45 meters. And he's irrigating 25 acres land. But we suggested him that instead of flooding irrigation, you plant orange orchids. There you need less water and you will get more care. So those fellows have understand our suggestions, and I think this earlier Kadu, I think he has planted the orange orchid. After that, I retired, so I am not in touch. Though I wanted to visit, but I am settling between India, Canada, and America because of my children are settled down. So I will show you some example quickly. This is another example. This is the topsoil. This is the weathered basalt. Then a massive basalt where you cannot get water. Then the water body is here. So farmers need this kind of information, where to drill the borehole or to what depth we have to. And that information is not given to the farmers. And that's why they, out of 10 boreholes, if they get water in one borehole, but in that process, they will sell their land, or they will borrow loans from the bank. And if in case, if they are not able to repay, they will commit the suicide. So instead of paying compensation 10 lakh rupees for one death, why not government is making use of the science to guide them? These are, you see, this is the recharge sites, fracture zones, and this is all the massive basalts. And here is one fracture. And if you put a borehole here, you can get plenty of the water. This is another source of water. This is the basalt. And this is some root of the basalts, and another water body is there. It was Kheda, that is Samudri. So like that, these are the examples. And I'm waiting if any agency can take our advice to develop these things. Kohli, Ramgiri. So there are, so these are the articles. They wrote very beautiful articles, but I could not succeed. I could not convince the government to finance these things. Then I moved to, in 2013, after my retirement, I got the extension. So I moved to, then I was not having any fund. So this is the Tawarja Basin. And here is the Murud station. In Murud station, railway station, this is the railway line. In Murud station, there is only one hand pump, and each family is allowed to take only 20 to 30 liter water. That is the situation on the station. So we conducted the survey at all these points, around 35 locations. I will show you the results. I will not go into detail. And this is some part of the Osmanabad, and this is the railway line. So you see, this is the 2D restrictive model. So you can see here plenty of water is lying in this one. Then we move to Karakota. Here there is a basalt, then intertrapean sedentary formation, again basalt. So what I feel that in Deccan Trape area, one should not go beyond 100 meters. This is 115. My instrument depth of penetration was only 150 meters. Here there is no sign of any aquifer system. So one can guide that you can don't put any borehole, so you can save the money of the farmers. There are several groundwater bodies. Only a farmer need where to go for the drilling. So these are the water bodies. These are the water bodies. These are the water bodies between two lava flows. No, as I told you, I was not having money to drill my own borehole. So I was looking for a borehole, for a site where borehole is working. So I reached to one site. That site is owned by Anand Yadav. So he was running a pumping set here. So we decided to conduct a survey here. So you see, such a beautiful water bodies here, and that is the massive basalt. So when we were doing the survey, the farmer, we are having a borehole which was not having a single drop of water. So he was insisting, sir, you find out water for me also. Then we showed him that in your plot, it is the massive basalt. Even if you 2 kilometers drill the borehole, you will not get the water. So only thing is, if this person is allowed, you can share this. So like that, and this is the geological section which we collected from him, the information. But this person also did a mistake. He drilled a borehole around 425 feet or something and could not get the water. This person, he get the water at 80 meter depth. But since he has a borehole up to 80 meter, this is the meter. So he wanted to drill borehole below more than this guy. So below that, he got a dry fracture. So this water it was not available. So that was the loss of this one. So if this fellow would have been guided that your water body is only 100 meter depth, you should not go below that one. He goes around 140, 150 meters. So he lost that. Anand Yadav told him that, sir, because of the insistence of my father, I am losing 30% of water. So this is the story. I very much wanted to have a borehole in the Murud station, but unfortunately, I did not get any support from my institutes or CSIR, because I applied for the emeritus positions and give this project to do work, but CSIR also did not find any useful work. So then I moved to IIT Roorkee to spend some time with the students. Now, this is the Ratnagiri districts. So this work we did with for a geothermal company based in Pune. They were having collaboration with Iceland company. So the Iceland people are expert in harnessing the geothermal energy for various industrial purposes. So here also we are looking for the water, but as temperature goes, the resistivity decreases. So the water, normal water, which will have a resistivity value in the range of 20 to 40 ohmmeter, here the same water, because of the temperature, the resistivity value will be less than 10 ohmmeter. So that is the criteria. And these are the, here I will show you the results. These are the hot springs. So you see, these are the sources, and the water is acting somewhere here. So if you will drill borehole, you will not target the source of the geothermal water. So we suggested that here you should put a borehole so that you can get the geothermal water. In this one, you can get water here. But this source is nothing but this water is migrated and collected by source. But this is having a deeper source. It may be having a magma. Because of the magma, heat of the magma, the water gets heated. So like that, we suggested them. So I'm only showing these two, but there is a 16 such restrictive values. Then in NGRI, where I worked, the director asked me, we were, those who have visited NGRI, this is the first gate. So director asked me that there was only one source of borehole here in the gate number 4. So that water was not sufficient. So my director asked me, why not you help to get water? So these red lines are showing the profile which I have. But the problem is there is no space. There is no space. So depth of the penetration or depth of the investigation will be limited. So I will show you some very interesting thing. And in granitic range, the resistivity range is like that. Soil cover will be less than 20 ohmmeter. Highly weathered granite resistivity value will be 20 to 50. Semi-weathered granite 50 to 20. So these two layer will be having the water and then fractures. And here in massive granite, there is no question of any water. So these values guided us in interpreting the results. So these are the some good source which we find out in NGRI campus. And this is a granite, massive granite, and this is a massive granite. In between two blocks, there is a fracture which contains the water. Here it is a surface water, it may be percolated from the irrigation of the garden, but here is the deeper aquifer system. Here is the recharge site, is an opening, and in between two blocks of the massive granite, this is the water body. So, and presently NGRI is tapping water from this side. Then we come across this is in a colony. So here is a water body, and this is the massive granite. So I propose a hypothesis that if there is a contact between the weathered granite, weather formation, and hard formation, so there must be some water resources. Though the depth of penetration was here 49 meters, and we drilled the borehole, and my hypothesis comes true. We got the water, and this borehole is using water. Water from this borehole is supplied to the colony. Here it is opposite to the groundwater buildings. And there the engineer invited the driller without informing me, and he put the driller, this borehole driller there. So you see, I have only investigated 26 meters where it was not the water, but this is the weathered zone, and this is the granite, massive granite. So with that hypothesis, I asked the driller to drill this ones, and up to 100 meters. So you see the results. So up to 100 meters, then a driller told me there are 5 aquifer system, fracture zones. I said, how you guess it? Then he said, sir, when we are drilling, so in a massive rock, the drilling will be slow, and in a fracture, we will feel a jerk. So that jerk indicate this one. To confirm his observation, we conducted the sonic log. So in sonic log, in that fracture zone, the velocity reduces, and this is the interval of time traveling this one. So time is more, then velocity decreases. When time is more, so these are the aquifer systems which encountered, which is based on the geological structure. Now the problem in Hardak area is that people are only doing activity up to weathered zone, and below weathered zone they leave in this one. And this is the pure water, flowing water, this example. This is the example from the CCMB. There is the water body where they are pumping the water. This is the IICT. Here is the water body, and it is near the Lipid Science Center. I was asked to find out that this in Director's Bungalow here, I could not get water, but in the sense, so they are pumping water from this region. Then comes the management. I will advise this one. CSIR reports drilling holes in the thrust economy. And he has interviewed one person, the driller. He makes 14 million, he can earn 14 million rupees by drilling 2 boreholes. So he is interested in getting money, earning money, not giving the water, because he is not expert at this. So that is the case. So what they are making mistakes, I will tell you. You see, in Hardak area, the casing is done only in the top weathered zone, and below is left without any zone. So what happens when you are pumping along with the water, sediments is also coming into the well, and those sediments filled this one. So even if there is a water, because of the filling of the boreholes, because due to the sediments, the borehole did not yield any water. So then the same aquifer will be drilled. So I suggested that you put casing for the entire one, and within the water bearing formation, you put a perforated pipe or screen, which is called scientifically screen. And then he said, sir, we do not have any screen. So I asked him to make holes with his welding machine. So he make holes. And this borehole is working since last 10 years. So that is I told him that use in a confined aquifers, which is below between two lava flows, you should have a perforated pipe. And it works in an NGRI, it works in the Vidarbha regions where we have drilled the boreholes. Now I suggested, because there are perennial streams in Tawarja basin, which are bringing water from the Bajargaon forest area. So if we will put at some places this check dam, so this example I have taken from some other papers, but just for demonstration. So groundwater level, which was earlier before the construction of a check dam, it was from the surface, it was 400. It has come to the 2 feet. It was earlier 4 feet, and it has come 2 feet. So check dams help increasing the water level, and that water will be available to the dug wells, which are connected to the this streams through fractures. And this surface water collected in the check dam can be also used. So you have two sources of water, surface water as well as the groundwater, conjunctive use. So as long as the water available in the stream you use, otherwise when there is urgency, you can use the groundwater. These are the some letter of appreciation the farmers sent to my director. So in conclusion, I should say the scarcity of water supply is not because of non-availability of the groundwater, but due to lack of the proper scientific investigation. Scientific investigation should be followed by development of suitable boreholes. Scientific investigations are going on. Aquifer mapping is going on by different organizations, but it is there is no follow-up action of the development. So unless and until mapped aquifer you are not developed, how it will produce the water which is used by the farmers? You cannot understand your paper and reports. Sharing of the scientific finding with the stakeholder to facilitate implementation of the development scheme. And there should be a license office like a groundwater authority. So if a farmer needs any investigation, he should approach that authority, and authority should approach the institutions which are expertise in doing such kind of survey, and then a farmer should be allowed to drill the borehole. So like that, you can make save the money. So there should be an adaptation of drip irrigation. In those areas, I have seen in Sangli, and I think people are 2 crops of jawar in summer also. That should be not practiced. And selection of the crop plants which require less water. So these are my colleagues who have helped me, Tyagarajan, Dr. Devashish, one JRF, Ratna Kumari, Dr. Vanand Rao, Liabai, and I should mention one Rangarajan, because I was demoted during my extension. So I was removed from the PI post. So I was brought under another person, junior person, Rangarajan, because I was not supposed to do this boring and handing over the wells to the farmers. So Rangarajan from the MLP project, he gave me money. So I carried out the work in the Tawarja basin. And those results are published in the papers. Anybody can see, and any organization, if want, I can help to develop those areas and to help the farmers. Thank you very much.
Thank you, sir. Thank you for lovely practical approach for the water solution. We got some 2 minutes. Sir, can we have one question? Any participant if wish to ask one question, we'll allow. In fact, we'll have a question and question at the end. But we got some 2 minutes.
Tushar sir, there is a question in the chat box by Mahadevan sir.
Okay.
Please read
Okay,
that.
how much power? Yeah, I'll read that. How much power was generated in Ratnagiri by differential thermal status of the groundwater? Your experience on the expense of confined groundwater in regions where no riverine systems are present?
I am not expertise. I can only delineate the geothermal water. How much energy will be harnessed, that is a job of the engineers and the experts.
Okay.
My second question was,
Yes.
in places where you don't have a riverine system, how deep have you to go for getting the confined groundwater? I am not worried about the unconfined water.
Sir, in my institute, what is system I was using, I can reach up to 115 meters, but up to 200 meters now system has come, which the spread length is around 1200 meters. So 1/5 of the spread length you can go, that is the thumbs rule. So 200, up to 200 meters they can explore the even confined or unconfined.
My information is that, the confined groundwater is of expanses of kilometers or miles, hundreds of miles. But you have stated that they are really, encompassed smaller regions. How do you explain that?
You see, I have selected some sites, but wherever you get the source of the groundwater, so you can make several parallel profiles, and then you can find out how long it is spreading. So
Okay,
for that one, you need more work, more funds, and that
You
is
have
very good questions. So you can
Ah,
suggest in one person, you can suggest many persons whose agriculture field is lying in that source zone. But the spacing between the two boreholes should be not less more than 300 meters, less
Right.
than 300 meters.
You have not done on the expanse of groundwater potential. You have not done it on the large expanse of groundwater.
Excuse me?
I think
You have not done much research on the large expanse of groundwater.
you mean aquifers? Probably, I would say the question can whether you
extends over miles. You have not done much research on that.
Sir, it is an instrument, it has limitations. You can,
Okay.
if you want to do the for a large extent, so you can take a profile, several profiles in an expected area, so that one.
Okay.
no,
Thank
Dr.
you.
Rai, you mainly focused upon the dry zone arid lands like Bede and all those, Ratnagiri, where groundwater for the given region to make it available, say borehole to whatever it is for needs of drinking water, not even for irrigation. Probably the question could be, that's okay, but suppose you have you carried experiment where there are aquifers you could strike to, where Dr. Mahadevan is saying that very large captured water body, I would say in the aquifers. So did you anytime find such an incident where when you had measuring and you could find a large body, I would say it's aquifer?
Now, if body is lying along the profile, then you can see that along the profile, and then there is you can make measurements in continuity to measure the same.
Right.
So that is a procedure called that you measure this one, and then the last point you start again measuring. Last point again you start measuring. So like that you
Okay.
can measure, but it is
Okay.
an expensive procedure.
Yeah, very
And in this one,
very
this one-
correct answer. Very correct answer. I am happy. Profile you have to study. Profile.
Yeah. Yes.
yes, sir. Profiling, yeah.
Yeah.
But I wanted to cover the entire area to see, and you are very much familiar. I have used your stratigraphy to interpret my results and other things. So
Thank
I'm
you,
very
doctor. Thank you, doctor. Your talk was very, very interesting. Thank you very much.
and that report is 1989, and we are in 2021, and still the problem is there. So it's very shameful for the scientists that
Right.
we are not able to solve the problem nearby one basin.
So Dr. Mehta will comment on that in his next lecture.
Yes.
He's here. The
So-
expert is here.
So there is a hand raised from Mr. Ramesh Singh. He has raised his hand. Probably he has a question.
Thank you very much. Dr. Wright, it was a very nice lecture, and what you presented, of course, the technology and the ERT is very well known, and we are able to delineate the groundwater. But the problem in Maharashtra, not everywhere you can find the groundwater. And the other thing is, see, in the climate change scenario, and every time Maharashtra is suffering with the drought condition, so then the problem is the groundwater recharge, and the monsoon is very erratic.
Yeah.
And when the monsoon is erratic, okay, whole of Maharashtra, from where we get the groundwater, this is the $1 million question, okay? And the question is, whatever the human activities are there, which is affecting the cloud formation and then the groundwater rainfall, that is the problem, and that leads to the drought condition. So whatever you have covered, there is no doubt that there is a less distribution of the water distributed in the pocket in Maharashtra. And of course, there are deeper water available, but that water we cannot like a tap. And as a result, in the Palghar and other regions, we are getting tremors. Okay, so that is another question. Okay, so here the whole of Maharashtra, because in the climate change scenario, there could be a lot of problems in future because how we are going to get the groundwater, that is the big question. Thank you.
You see, the groundwater is mostly helpful when there will be drought situation. This ERT system also give you the suitable site for recharging. You cannot make a recharging site everywhere. Where the aquifer is exposed, then only you can put a you see, drought situation, more than drought situation, the people are suffering because of the non-availability of the groundwater, though the groundwater is available. So our job is to locate the groundwater which can be used by the farmers in case of the drought. You will be surprised that in the summer, I approached one farmer. He said that I can offer you milk, but I cannot offer you water. For the cattle, they are saving water, very limited water, because we need water to pour in the electrodes to get a better connection. And it was very difficult to find out water to put into the electrodes. That is the pathetic condition. And I have shown you there are several places, even in Tawarja Basin, this Chandrabhaga Basin, there is a Mordham dam, and that water is left for evaporation. There is no any irrigation system developed to make use of the that dam water.
Correct, very correct.
Yeah. Okay. Thank you. See,
so it is the failure. It is the human failure. It is not the natural scarcity of the groundwater. It is the human failure.
Very true. Thank you, Dr. Rai. We got lots of questions coming, but we'll have a separate question and answer session at the end of the meeting. We'll continue this session. We'll move to the next eminent personality who's going to talk about. I'll request Deepa to invite Mr. Mahendra Mehta, sir, who's from Ministry of Water Resources. He's going to talk about water security for sustainable development. Over to Deepa, please.
Thank you, sir. Good morning. I am here to introduce our next speaker, Shri Mahendra Mehta. As sir has rightly introduced him, that he is Commissioner, Ministry of Water Resources, Government of India, New Delhi. He is an MSc Tech in Applied Geology with specialization in groundwater from Roorkee University. He has membership of many professional associations like Fellow of Maharashtra Academy of Sciences, Pune, member of Indian Water Works Association India, member of IWRS India, and many more organizations. He has held important positions other than the current position. He was a member of Central Groundwater Board and Central Groundwater Authority, Director of Administration, Central Groundwater Board, Regional Director, NWHR, NWR, NER, Central Groundwater Board, Program Manager in Jal Bhagirathi Foundation, Jodhpur. He is also an advisor for Global Hydrogeological Solutions, an NGO which is based in Delhi. He's a consultant to Government of Gujarat for preparation of feasibility report of artificial recharge to groundwater in different basins. He is also associated as a groundwater management expert in DTL, EU, SPP, TA team. He is an independent consultant for clearance from CGWA and assisting state governments for better waste management. To mention more, he has more than 46 years of experience in planning, implementation, monitoring, and supervision of projects and schemes related to groundwater exploration, development, rainwater harvesting, and artificial recharge to groundwater in minor irrigation, policy planning at national and state level. He is also associated with Provincial Hydrogeologists as a Provincial Hydrogeologist, Southern Province, Republic of Zambia, part of EU SPP TA team. He's worked as Program Manager in Jal Bhagirathi Foundation. He has authored more than 85 scientific reports and published 75 scientific papers in national and international seminars and symposiums. His association is at national level, state level, as well as international level. So if the biodata that I have is a very exhaustive and very detailed information about Sir. So, and the topic that Sir is going to talk about, as mentioned by Tushar Sir, he's going to talk about water security for sustainable development. Good morning, Mehta Sir. Over to you, Sir. So you need to unmute, Sir. Mehta sir, you're not audible, sir. No, sir, you are still not audible.
Please unmute, Mehta ji.
Sir, he's unmuted, but probably his earphone is not connected well, so probably he'll have to select. No, sir. No, sir.
You think he's unmuted?
Yes, sir, he's unmuted. Sir, you can just remove the earphone once again and plug it again in the system.
But I have done it.
Yeah, now you're audible, sir. Now you're audible.
Okay, okay.
Yeah.
You can see my slides?
Yes, sir. Yes, sir.
Thank you very much. Now, giving me this opportunity to share my views, I thank Pawan Saab and others who invited me for this auspicious day. Unfortunately, or fortunately, my name is also Mahendra, which is associated with the water. So that's what I have. So today, a lot of things we have been talking, like climate change, its impact on groundwater. I will specifically how the groundwater is likely to be affected with the ground because of the climate change, and what preparation we should do and prepare ourselves for the future, because the groundwater is the main source of water in our country. It caters more than 50% of the urban area water requirement, 80% of agriculture. So we have to be prepared and ensure that we get proper groundwater in the future for our future generation. There is a confusion between the groundwater as well as climate and weather. Climate is different. We are talking about climate change, not about the weather. Short-term changes in the atmosphere, variables such as the temperature and rainfall, is associated with weather. Weather is what is happening outside right now. I'm sitting in Goa. It's very humid and hot. But maybe it's not a climate. Long-term state of atmospheric variable like rainfall and temperature, which is talking about the climate, and climate occurs over the seasons or along. It may be a winter, climate may be winter, but there may be rainfall, weather may be rainy. So there is a difference between the climate and weather. Human activity is changing our climate. Some of the activities by which we are interfering in our atmosphere and changing the climate is a natural variation of our Earth along the sun. That is also changing. Volcanic eruption, which is we have seen last 2 years apart from the pandemic of corona, we have seen this is also happening. And human activity like factories and this more carbon emission. So that is also likely to affect the climate. Human activity is changing our climate. The atmosphere acts like a glass of greenhouse. Sun rays hit the atmosphere and some are reflected. Some passes through and reaches to the earth and the earth becomes warm. Greenhouse gases heat from the earth, traps the heat from the earth, which is radiating back. The greenhouse effect make earth warm enough to live on. So that is the human activity which is taking place. Human activity is changing our climate. Greenhouse gases are increasing like carbon dioxide, combustion, burning of coals, fossil, deforestation, methane and atmosphere, landfills, a lot of garbage we are generating, and that landfills that gives the atmosphere methane gas. Agriculture, growing of the rice. Rice was not a crop for India. It has come into India. Now growing of the rice also gives a more methane. Livestock, lot of livestock, it will have more methane. Human activity, ozone from the exhaust, CFC from the aerosols. These are the human effect we are affecting. Sorry, I have to something. This is coming on way by me. Oh shit. Now we have already changes our climate. The Earth has warmed, which is a well-known fact. The Earth is the average temperature is increased by 0.74 in our last century. To us, 0.74 centigrade is very less in a century, but it's really going to affect or affecting our climate. We have already seen changes in our climate. Rainfall pattern has changed. The world has seen the changes, amount of intensity, frequency, type of precipitation. If you see nowadays, the rainy days has become less, intensity is more, and due to its last over 10 years, we have seen a lot of floods is coming because the intensity is high, and it is going to happen. We have to prepare ourselves. Rainfall strongly characterized by the variable year-to-year variation. Rainfall always changes because we are in a tropical part. We are a tropical country, so rainfall will vary from year to year. But over the years, the intensity of rainfall is increasing because of that. A lot of flood generation and surface runoff increases and floods are coming. On the contrary, during the non-rainy season, so-called, our rivers are by and large dry, becoming dry. So this shortening the period of the rainfall is going to affect all human life and agriculture activity. We have already seen the changes in our climate. Global sea level has risen. During 20th century, average increase was 4.8 to 8.8 inches per century. They may be 1 to 2 millimeters per year, but it looks very small for us. But over the years, what has happened? Earlier also, the sea level risen, there are a lot of temples gone in the side, like in Gujarat. So again, if the sea level increases, we are going to have a problem. Like Bombay will have a lot of problem because all along the Bombay is situated. The expansion of ocean water, melting of mountain and glacier and small ice cap, that is happening. That our glaciers are melting. We have already seen changes in our climate. more extreme weather, tropical storm, hurricane, frequency very considerable from year to year, substantial increase in intensity and duration since 1970, which I already explained. You see this, floods in Rajasthan, but we cannot never thought a flood in Rajasthan came on that too in the western Rajasthan. And I have seen this flood myself, where the entire village, everything was gone. So this is what is going to happen or happening. Climate change impacts. Somebody has to unmute, please. Health impacts, heat-related deaths, infection, diseases, air quality, respiratory illness will come. It is likely to come. Agriculture, copy, irrigation demands, and pest management you have to take care. Somebody can unmute.
Yeah, Rakshada Ingre to unmute, please.
Yeah,
Mute. Rakshada Ingre. Mute, please.
somebody is
Hello.
Who is that, please?
Rakshada Ingre.
forest impact, health composition and productivity, water resources, changes in precipitation, water quality, and water supply. That is what we are going to do. But even the wildlife also will affect it. Coastal areas, erosion will be more. And all these things put together make the life more complicated, more challenging. Possible impact of climate change on groundwater recharge and availability. Increasing trend of surface temperature. No established significant trend in rainfall on all India basis. Decreasing and increasing trends of rainfall in some parts, which is happening. Like Rajasthan now, it is increasing. Some parts is decreasing. Soil moisture, it will affect. Recharge to groundwater, it will affect. Imbalance development of groundwater due to extreme events because requirement will more, so people will start more machines will come, more tube wells will be drilled, and more extraction, and that's why the groundwater quality as well as the groundwater level will go down. Groundwater availability will change time to time. Increased trend of surface temperature will take, sea level will rise 1 to 2 millimeter per year. You see in the India, the evaporation losses from surface water bodies is as high as 3.5 meters. Suppose if any surface water body is less than 3.5 meters in the western Rajasthan, and you don't even take a one bucket of water, and within a year it will dry. That's why you have seen in the Rajasthan, especially all the talabs have very deep. They are very deep, not more than 10 meters deep. And that's why you get the water in the summer. These are the things which they have learned by practice, no scientific reason. But the practice they have, I will discuss these issues afterwards also. Impact submergence of low-lying coastal areas. 40% coastal area could be inundated in case of 1 meter rise toward the water. Inland extension of saline intrusion. The seawater will come inside more, and even the groundwater will become saline. Seawater ingress, coastal aquifers and groundwater contamination will take. It has taken place in Chennai, and that's why the Chennai water supply was a problem one time. So this is our issue. If 1 meter rise in water, sea level, the front of the unsaline and saline groundwater comes around 8 meters inside. So this is the 80 meters inside. This is the relation. Rainwater harvesting and also mitigation measures are the rainwater harvesting and artificial recharge. Priority areas which we have to give the overexploited, critical, semi-critical, as assessed by the Central Groundwater Authority based upon the development. Base documents available, prospective plan is available for utilization surplus monsoon runoff, and master plan for artificial recharge of water is available. Guide on rainwater harvesting and manual for artificial recharge is also available. But Are we doing? No. We are doing sectoral basic rather than the holistic approach. Action plan, preparation and implementation of state-wise groundwater bill. It has been done, it has been requested several times, but unfortunately, political will is required to prepare and implementation. Prepare, all scientists can prepare, all engineers can prepare based upon their knowledge, but political will to implement, because unfortunately in India, water is associated with the votes, which we have to come down, and water being the state subject, government of India also cannot do anything except the suggesting. Central Groundwater Authority was created, but they are not able to work. It was created only because under the Environmental Protection Act, so that it can be used throughout the India. But unfortunately, so far, after maybe 20 years, 35 years, still it is not able to perform as required. Preparation was state-wise implementation of rainwater harvesting and artificial recharge. Okay, it has been done, but same thing. First phase of implementation, overexploited units, mandatory water harvesting and artificial recharge in urban areas. Urban areas, we are using huge water, but are we managing proper? Even the building bylaws, roof tank harvesting is there, but it is constructed but not maintained. You can construct anything, but maintenance is mandatory and it has to be maintained properly. If you don't maintain, but nothing happens. Unfortunately, in urban areas, we do not have the separate sewage and separate stormwater drain. So what happens when the rainy season comes? Runoff has increased because of concrete jungle. A lot of water goes in, all the water goes through the so-called storm drain or sewage drain. Even the cities where the units have been installed for treating the water, they are now unable to treat because they don't have that much capacity at that time when there is a peak rainfall. So this has to be looked into, and at least new planning of not our cities but the colonies, we should have the proper storm drain, and that water should be collected and can be used for many purposes, including the flushing of the toilet, gardening purposes. So the demand maximum water in our house we use for our toilets. Every person goes 5 times toilets and 5 liters, 25 liters goes down. Can we not recycle it? This is one of the things which we have to discuss and ensure that it happens. Second phase implementation is critical in other ways. Conjunctive use and management. Priority areas, urban areas. That's what I am telling. Urban areas, because we always blame the villagers, but we are taking water from villagers to our houses. From where? Otherwise, within the city, we cannot get this much water. So urban areas is a priority areas for conjunctive use. Use the treated sewage water. Has to recycle after the proper treatment and to be used for other purposes. We may not make it for domestic purposes, but at least for gardening, washing, dual piping in the city for the flushing purpose. This has to be done. If we we are not doing, we are going to suffer in future. Major irrigation commands, also conjunctive use has to be done. Quality infested areas with surplus surface water to recharge the groundwater if possible. Maybe groundwater is already saturated, aquifers are already saturated. But there are, one thing I want to clarify, that there is a misconception about the confined and unconfined aquifer. Unconfined aquifer may be there, but every confined aquifer becomes unconfined somewhere. And we have to do the aquifer mapping, 3D modeling, based on the available data and data gaps we can fill it. And then if you want, we are taking water from the confined aquifer. If we don't recharge properly, it will become also unconfined. And at times, the effect of the earthquake becomes really huge. So we have to take care of all these things. So three-dimensional modeling and recharge the areas where this confined aquifer becomes confined, so that we are properly control the entire thing and the supply remains the constant. Installation dual water supplies, which I have talked, water recycling and reuse is there, implementation of community use management, yes, plant to command area. We are going top down. No, we have to go bottom up. What the community wants, you tell this is the water for your community and you have to manage it. This we have done in the Jal Bhagirathi Foundation through the participants of the villagers. We used to get it done the pond cleaning and desilting and then hand over to them. A season, some of the places they have become so much aware that if somebody is lifting water through the tanker, they used to charge the money, maybe 50 rupees. Within the village, 50 rupees. Outside the village, more. And even they have put a watchman there. When next time I went there, they say, now we know how to manage our things. So that's the reason. Earlier, we used to have this well is of Kumar, this well is of Suthar, this well is of a Brahman, or this pond is of that. That community used to take care of that. Maybe caste system was bad, but that community system was there. But now if you go to village, they will say this well is the panchayat or that well is the government. They will never say it's a village. So this mindset has to be changed. Augmenting a fresh and water with brackish water for water supply. This can be done because the water is very fresh for one aquifer, or you are getting a surface water supply. You can pump out some fresh saline water and use it even in command areas. It can be done in Bikaner, in the northern part of Rajasthan, where the water is saline. It should be done. It is being done so that you can maintain the proper water supply to your crops. Recharging deeper aquifer, your shallow aquifer by construction of connector wells in waterlogged area. This can be if you have a confined aquifer or if you have a deeper aquifer which is having a storage capacity to store. Connector wells can be done, and so upper well aquifer will recharge well. It has been done and it is found very successful. Institutional regulatory measures, all okay, central, state, but the basic problem is water is not in concurrent list. It's a high time for India to bring the water in concurrent list. Otherwise, every state will have its own problem. We know there are more than 35 cases for the sharing the water, surface water is going on. So this is the real thing which we have to look into. Increase the groundwater efficiency. Various process turn result, reduce the groundwater withdrawal, use the better efficient method of irrigation, water related energy demands, and air pollutant emission. So you have to develop that. Cultivation of salt tolerant crops in arid and semi-arid region, dual water supply and system in urban settlements. Yeah, there are crops which can survive in a slight saline water also. Introduce the micro irrigation techniques in groundwater irrigated areas. Yes, it should be done. But again, I will insist on here. If you go to Rajasthan or where the winds velocity is very high, sprinklers are not very good. It is better to go for a drip rather than sprinkler. Encouraging the farmers to grow less water consuming crops, which is very easy to say, but they are. Take for example, Maharashtra. Drought prone area is a belt for sugarcane, which is a highly water intensive. Why it is going on? A lot of sugar mills are there. Why it is there? Earlier speaker told that in Vidarbha, a lot of people are committing suicide because of non-availability of water. I agree. I was there for about 10 to 12 years. But why not? Why in Rajasthan people are not committing suicide where the water is not there? Because of the holistic approach is not done. Government banks have their own target to give the loan, and they go on giving the loan, and they start when they go for recovery, farmer doesn't have money money to pay, and they commit to suicide. Why not a holistic approach? When the IMD say this will be a drought here, banks should also stop giving the loan. It is better not to give a loan rather than giving a loan and then asking and the people committing a suicide. It is unfortunate. So we are not taking holistic approach. We are still on sectorial approach. So this has to be changed. Incentive for management, a community well, construction of recharge structures, energy saving pumps, this has to be done. Concept of virtual water, I think I will not go into the photo projection and this. That is easy to tell, but what I am going to cook in my kitchen, nobody should be there. They should plant, this is the water available. Now you do whatever, this is available for a village, whether you plant 10 acres of rice or 50 acres of wheat. It is up to you, but quantity of water is fixed. You cannot use more than that. That concept, when the villagers will get, then they will try to change their cropping pattern rather than, because I'm a rich man, I can drill for rich farmer, I can drill 3 tube wells, that's all. And then water, electricity is free. So why should I bother? Let the pump be on because so that's how misuse is taking place. Nothing should be made available free. You may be give some subsidy to agriculture sector, but free electricity has caused a lot of problems in Punjab. I have virtually seen pumps are running 24 hours, water is going down to drains, virtually going to down to drains. This has to be looked into. Politics has to take care of this. Politician has to care of it. We have surplus some water, which we have a surplus. We have to transport to other states, but same thing problem comes. Water is in there, not concurrently. So people don't allow to go. These are the issues which is going on last 30, 40 years. But unfortunately, we are not able to resolve it or thought it because of political people. Incentives for the management, community wells, construction, recharge structures, energy saving pumps. This is all removal of free power supply for agriculture sector, other things. Coastal areas, same problem. We have a problem, priority areas where the water level is going down and seawater encroachment is taking place. To prepare the groundwater condition and coastal tracts of India, based documents, action plans have to be prepared. One thing also, the data is the most important. Data collection, proper data storage, sharing of data, it should be available on the website. Hydrochemical studies, formation of water to establish saline and fresh water. Modeling studies, okay, these are the studies. But how to, we should do it. But apart from doing it, we have to translate on the ground. So the common people is not interested in models. Common is people interested whether he will get a water or not. How to do it? This is our thing. And to tell them in a simple language, that is different. Now you see, I am going slightly out of this contest. Now, community toilets for all the people. It's a wonderful idea. It has been done very nicely. All the people, it should be done. But what about the sewage which is being generated from the toilets? Even in the village, how we are going to control it? What we are going to do it? Are we going to allow to go into the groundwater and pollute so the nitrogen or everything increases and groundwater becomes unsuitable for domestic purposes? We have to think, we have to, right now it's not, we are already late, we have to plan right now that the sewage from the villages has to be taken care so the groundwater is not polluted, because which is the base water for our domestic purpose. This has to be done. This I have already discussed. Recurrent floods, this will come. I don't think changing climate, they expect the influence of both results. Increased incidence of flood and rivers likely be more in the future. Groundwater withdrawal during the summer may decrease because the rainfall, however, during the winters, the demand of groundwater will increase. This is going to happen of climate change. More surface water reservoirs will be required because the runoff will be very high, because the period of rainfall will be less. So we have to construct more reservoirs and ensure that this is done. Otherwise, we will have a problem for more floods and losses from the flood. And the recharge to groundwater will be less because the period of contact of time of the water and the soil will be less. Erosion activity will be more. Evapotranspiration losses shall be more, especially in the areas where the groundwater levels are shallow, because even from the groundwater evaporation takes place because of the temperature variation, hot to hot, the movement will be up. Synergy electricity, these are the self-explanatory. I don't think I will go more details in these, but irrigation department, watershed departments, they have to work. Irrigation equipment, this has to be taken care. Water supply agencies, groundwater recharge, master plan, electricity utilities, rural electrification corporation. These are the issues which we have to bring stakeholders under the one umbrella. We holistic approach, sensitization of stakeholders at grassroots level. That is the most important because India is the country where we have all very complex, hottest, highest rainfall, drought or least rainfall. We have a cold climate, very dry climate, very hot climate. So India is not other countries. And then apart from that, we have a rainfall which is very different from the other countries, other part of the world. Constitution of Groundwater Management Authority regulate the groundwater development management on scientific light. It should be done. Formation of Farmers Association of groundwater use, particularly for the irrigation. That's what I told. This is the volume of water available for you. Now you among the farmers decide what is to be done and how much is to be distributed. Adoption of water conservation techniques for irrigation. This should be done. Introduction of a hybrid variety of seeds requiring the less water. That should be adopted. Adopting conjunctive use of surface and groundwater, it should be done. Otherwise, what is happening in the canal irrigated areas? Take, for example, northern part of Rajasthan, again I will go. There is waterlogging taking place because there is a clay layer at very shallow depth. Water doesn't irrigate, applied water doesn't percolate down, and waterlog area is increased. Adopting conjunctive use of surface and groundwater, development of decision support system, it should be developed and made available to all the people on site. Training and capacity building for sustainability, it has to be done for top also as at the bottom also. What at the top we know everything, it should be done. No, time is changing. We should learn from the people what they want rather than scientific CES, SOI. Nobody is bothered. This is the common people, how you will get sustainable water supply. That should be the approach. Sharing all information with stakeholders. Stream flow prediction is the most important, but otherwise the floods are going to affect downstream people. Utilization of increased base flow and flood water. This is because most of the rivers, southern rivers in India are all they are not snow-fed. So base flow is from groundwater. So we have to ensure the base flow is sustainable so that downstream people get the water throughout the year. Strict control and ensuring that the fresh saline water interface is not disturbed due to aquifer development in coastal areas, which is very, very important. That's what I want to say. I will also like to say something. Take example for the certain places where the water scarcity is there in Rajasthan. What the evaporation is very high, I told you. At least 10 to 8 to 10 times of the rainfall. What they do it? They take the water and store it in the takas, underground storage, where they don't allow sunlight to go inside, so the algal formation doesn't play. It's an age-old traditional practice. What we should do now for areas where the evaporation losses are very high. There are chemicals available now. We are eco-friendly, wave-friendly, and it can be used to do, suppress the saturation. Even 50% evaporation losses from the lakes, we are able to control. Our water supply and recharge to groundwater increase many-fold from trees, lakes, and water bodies. This has to then, and we have to rethink for the Dharma. Holistic approach we are not going to do. We are not going to ask the banks not to give the loans this year more than this. We are going to suffer and poor people will lose. And especially in the drought-prone zone of Maharashtra, it's a high time to change a coping pattern. Thank you very much.
Thank you, sir. Thank you. What a in-depth study. And the message is very simple. Act now to save planet. So we move on. I move on to the next speaker. We have 2 minutes. Can we take only one question?
Sure.
Only one question. Anybody like to ask directly, or I should read from the chat? So there is a question: how useful is rainwater harvesting in increasing groundwater capacity?
Oh, it is very, very, very good. I will tell you where we have done it. Even in Maharashtra, you were talking, Maharashtra, we have done it. And the water level has changed about 1 meter per year. So rainwater harvesting proper location in hard rock is a must, so that the fracture zone is exposed or shallow aquifer is there. You can recharge to. If there is a, we have done in a lot of places, like in Jaipur, I think India's largest rooftop rainwater national ball bearing company, more than 10,000 square feet. And we have prepared a proper recharge intake well after filtering. So at times you have to do the simple way. If the industries are doing, you can have a recharge well which directly takes the water into the aquifer, so the losses of the recharge water is less. Otherwise, in between the moisture absorption is there and the actual recharge takes place.
Thank you, sir. Thank you very much. In fact, after the lunch break, we'll have a panel session with the panel discussion with question and answer. We'll have all the
hopefully, I will present. I am in Goa. I may go out. Hopefully, I will be there.
Okay. So,
Thank you.
all the people who are from different places, all the panelists, they request to be there on this list. So we have a very next speaker who's going to talk about, as we talked about the climate. So this is a climate water resilience. This is a topic, and I have a privilege to introduce a very special person known to me for quite long, decade ago, Dr. Rakesh Kumar. He can say he's our local guy, like, with Mumbai. His biodata is very huge biodata. Basically a doctor. He has worked for National Environmental Engineering Research Institute, that is NEERI, part of a Council on Scientific and Industrial Research. He is at now, he has left us Mumbai now, he is at Delhi now. Okay, and he's completed his MTech in Environmental Science and Engineering from IIT Mumbai, and again later got PhD in Environmental Engineering. He has been a visiting professor not only in IIT Mumbai, but he has been to university, Drexel University under Obama Singh Education Initiative. He has got main area of expertise in the development of appropriate technology for environmental quality improvement, encompassing the field of air pollution, particularly vehicle pollution, hazardous waste management, wastewater treatment, and disposal besides climate change, and health-related subjects. Urban environment management is another area where the numerous work related to carrying capacity, urban heat island effects, waste management, and water sector analysis has been carried out. His work has been appreciated by getting lots of awards, and the very notable award is conferred upon him, the Environmental Leadership Award by US Asia Environmental Partnership and US Aid for the year 2004. 2005 for outstanding contribution in improving quality of life for the population of Asia. He's got a WASMIC award for 2012, then got lots of many awards. Like it's long list. Rakesh Kumar has even got 12 patents, out of which 2 are international patents, which are the devices he has created particularly for the pollution control. So it's all over to sir. We'll have climate and water resilience by you. Thank you. Over to Dr. Rakesh Kumar. Welcome, sir.
Thank you, Mr. Desai, and good morning, and we are on the cusp of good afternoon. Big greetings. Can you all hear me well?
Yes, sir.
Okay.
You are heard well.
So all the SOCLEEN, I would say veterans, Dr. A.D. Savan, Dr. T.N. Mahadevan, and I see a lot of other people also have joined. And this is a time when we actually celebrate the process of all those who worked for SOCLEEN in the past and those who are working now today. And I'm sure there'll be a set of generation which is wanting to take it forward future. So it's almost for me, as I would say in-house speaking as such, Dr. Sawant told me. So I was looking at the 2 excellent lectures we got done this morning, one by Dr. Rai and the next one by Dr. Mehta. Very, very interesting and very, very powerful. So I'll share my slides. So I'll have a very quick, small presentation to all of you. And just confirm if you all can see it.
Yes, sir. We can see that.
Right. Thank you. So although this was very elaborately done by Dr. Mehta in terms of climate change and water nexus that we're talking about, but while we know that there is a danger, there is a issue of what we need to do about it, it is heartening to note that in India right now there are a lot of groups across different states who are doing good amount of work relating to this area of water conservation, groundwater recharge, and related things. And the picture that you see here is an example of the work which is being done to revive Shahadra Lake in Delhi, which had become dry for almost like 7-8 years, and now it's almost you can see on the right hand side the water has started flowing in. And very interestingly, the water here is coming from the sewage which flows nearby that gets treated, and that's how the recharge of the water body takes place. So when I look at this, I will not go into details, but what is important here is that we are now completely in a knowledge game where we understand exactly what others understand in different parts of the world. So when we talk about climate change, it is no more a case where we could keep blaming others, but this is the time when we have to take our own leadership, and India has to start taking that leadership, which it has done in a bigger way. If you see the number of solar parks and solar related energy projects that has been taken up, is extremely powerful and much more than what we could think of. I just wanted to see you, show you some of these, working group 1 IPCC report where it talked about that what all changes are happening in terms of climate change. And when we are talking about reduction, overall reduction, then we are looking at capping it at 1.5 degree. If we go to 2 degrees and above, we are going to have a serious issue in terms of not only livelihood, but jobs and even mere survival in many areas of our country is going to become difficult. World over, of course, we should be worried about, but at this stage, we should be looking at how India will be responding to the whole thing. So when we look at these, we have these issues of severe weather events, which we all now completely understand how it is happening. The changes which happen in vector ecology and vector-borne diseases. And after this COVID thing, although we can't possibly say it happened because of climate change, but related vector-borne diseases have become so prevalent and so difficult to deal with. So when we're talking about all of these, the center of all of these issues come to water problems. So if we can't have water at the center of our development, we will be doing disservice to ourselves. And that's why I call it in the domain of architects, they talk about transport-oriented development or transit-oriented development. Whereas in our case, I think we should be talking about water-oriented development. So if you see all the cities which got developed and all the major, civilization, they actually occurred next to the water, and because they realized that this is the critical component of our survival. So when we talk about who is at risk, you will find that most of those places where we have the interface, they're at very high risk. So coastal regions, mountainous regions, polar regions, small islands, of course, and mega cities, cities like Mumbai, Delhi, Chennai. So India has almost now 6 megapolises now, probably one of the largest in the world. And we will be dealing with it more in an intense way because our population density is also equally high. And when we talk about for the similar situation in any other country, when we have less population, and when we compare ours, we will be putting more number of people at risk when we talk about it. So I'll not share these numbers again known to all of you. What is the total water available and what is that we are going to have. Niti Aayog has also given this warning. Now the challenge for all of us is that how do we convert all these Niti Aayog statements or any statement made in IPCC or any of the decision-making body in our country. So what is important here is when we do mapping, the so-called threat table that you see here, that when we look at different zones starting from Western Himalaya to Kutch, Deccan Plateau, all of these here, and different states where they are, now we have fairly good idea where is groundwater depletion issue, with whether we have high or medium to high or depletion, say in hills or Arunachal Pradesh and all that, and how it is combining with the rainfall. Now, why it is important here is that on one side, when we have high depletion, and if our rainfalls are normal and high, then how is that we are unable to manage this whole thing? And that is where the question comes in, that how do we bring the science and technology aspect of managing these water that we get? And country like ours has more difficult job compared to temperate climate, because we get rains only during monsoon season. Otherwise, and that too, there are many places in our country where even during monsoon, the rainy days are becoming less and less. Starting from even 10 days, 15 days, 20 days, not beyond that. So it is important that how do we deal with this water which comes in. So when we look at adaptation relating to water, in this particular case, we don't need to only talk about water quantity, but water quality, as was also pointed out by earlier speakers. Because if water quality is not looked at, we will be dealing with a lot of disease in our society. And overall, the cost of living is going to go up due to health cost. And then some cases of adaptation to inland flooding, which happens very, very often in our country when we have extreme weather situation. Just to give you an example, why water quality becomes critical for us is because if you look at the sewage which flows in many of our drains and so-called rivers, they're nothing but 98-99% water and about 1.5% contaminants. So what we need to do is take care of that 1 to 2% of contaminants, and that is going to be our major water sources. So when we look at technology landscape, when we combine that due to impact of climate change. So when we look at water supply issues, we have reduced surface water availability due to precipitation changes, increased evaporation, which was also pointed out by Dr. Rai. What we need to do here is to move things in a way that we look at water collection, storage, distribution techniques, improve water use efficiency, water recycling and reuse. Wherever we have reduced groundwater availability, improved water use efficiency, and increased sustainable aquifer recharge, which was very well explained in the first lecture that we heard. What is important here is that all that science and knowledge which is available within our own country and elsewhere, how do we convert into a pattern so that it can be implemented? Now, the issue which I keep repeating, and I may be possibly wrong, that we do not have a dearth of knowledge What we lack right now is how do we implement them, and how do we implement at a level that is scaled, which reaches to each and every one in the society. When we look at stormwater management, again, similar thing, we have increased flooding. And for this, it is important that we have weather event prediction and early warning system. So some cities have started doing it, but most of the cities, the tier 2 cities, are still struggling with what happens when the flood happens, right? And this flood management is something which can be actually used in a right way. If we do it in a particular right way, they can actually be used for groundwater recharge. And when we come to third category of water quality, when we have more abstraction of water, we have salt water intrusion and reduced surface water quality. We have a lot of technologies which are possible to do. So in salt water intrusion, there are methods by which we can create barriers for salt water, increase sustainable aquifer recharge, which has been done in part of Madhya Pradesh and part of Marathwada as well. But these are, again, as I said, there are only 1 or 2 good examples, not scaled. When we talk about reduced water quality, we have cases where we need to do increased water treatment, improve stormwater management, and then prevent contamination of surface water. Now, this is where we are struggling. Delhi has more than 600 water bodies, but most of them are contaminated. Bangalore is struggling with more than 250 water bodies, which a city which was called City of Lakes is struggling with contamination of most of its water bodies. So, but there are people who are now pushing it. How do we move forward to take care of it? So in terms of technology spaces, we have mostly talked about rainwater harvesting at rooftop rainwater harvesting. What is needed now is large scale, where we are talking about 500 to 1,000 acres, hectares of land, where rainwater harvesting can be done. An example of government of Maharashtra, where it started doing in Jal Yukt Sivar project, that was an example of scale. I wish that that project continues, and with whatever little tweaking which is required based on the knowledge that we gathered, we need to do large scale rainwater harvesting of that way. Surface water storage, no brainer here, because the whole of West Bengal and Bihar and part of Jharkhand, which is struggling, I think even part of Uttar Pradesh as well, which is struggling with arsenic and groundwater. The only way you can, and I would say the cheapest way which we can deal with this arsenic related issue is to use surface water. Traditionally, all of these areas have had groundwater which is very easily available, and people have exploited quite a bit, but now arsenic has come into food chain completely, and we can't possibly deal with some kind of treatment. Treatment can only be done where it's extremely important and extremely necessary. But otherwise, it's a cause of concern for us. Interbasin water transfer has been discussed many times, but I would suggest that interbasin water transfer should be done only when we have understood the ecology of it. Just pumping one basin water to another basin is not something ecologically favorable in most of the cases. And there has been example of failure in China and also in Australia. So some projects which we are trying to do, or which we are trying to advocate, must be undertaken only when we have done adequate understanding through studies, and also checking it whether this is going to work. And the rest of the other ones, which is all known to us, aquifer recharge, water loss reduction technology, and the one which is very important here is, which is being discussed across India, that most of the cities have water leakage and related losses ranging between 35 to 45% of water which gets lost in leakages. So if we can't do this, we are unnecessarily creating more and more dams, and we are unnecessarily pumping a lot of water from the ground and then just leaking it outside. That's very important. In water quality, there are a lot of options now available for wastewater treatment. I'll not go into detail. But inland flooding can be managed through stormwater management and bioswales. It is a process by which you can actually stop water slowly for it to move. And this, not only that it prevents flooding, but it also recharges the ground. So structural barriers where we can't do flood rate management in direct way. And then there are some non-structural barriers to flooding, which is like, if I take the context of coastal areas, when we talk about non-structural barriers, they are mainly mangrove forests, which are on the coastal side, which can actually prevent flooding to happen. And whenever it requires, when the storm surges happen, the flooding can possibly be minimized. It possibly cannot be completely taken care of. There has been a lot of work happening at the central level, where Niti Aayog and Netherlands have signed some kind of MOU, where they are looking at in water sector decarbonization, energy transition, because water supply itself is using a lot of energy these days, which has been noticed in many places. Water security and climate adaptation, rural India, there is a program in India and Germany. Similarly, there are other programs of Niti Aayog which are connected with mainly energy, and some of them with water. Some of the other policies has been, when they are talking about, which looks nice, that development of public health and management cadre. These are the kind of public services, if it is created, they'll be able to deal with all the urban areas related issues, particularly water, sewerage, and related urban related issues. They're also talking about public health surveillance India. This is very interesting, composite water management index, that each state or each city, how are they managing their water, and based on them, the way we have Bharat Swachhata Abhiyan related ranking, one could actually have these kind of indexes, which will be done by Niti Aayog as we go ahead. Lastly, I just wanted to highlight, because we have a lot of people who are here from research and academic background, that what are the research institutions and academic institutions who can possibly do work in this domain. So there is a need of development of improved and accurate prediction of precipitation patterns. And when I say improved and accurate prediction, right now we do get prediction from IMD, which says that rains will happen and so much will happen and things like that. But it needs to be granulated to a smaller scale, where we can possibly say, do we have prediction for 2 by 2 kilometers? Do I have prediction for one particular ward or few set of wards? Because if you see in any cities, the IMD predictions look good many times, and sometimes they're off. And it's mainly because we have not been able to work on the climate model and prediction model, which is giving us very, very concrete data at a point. Then develop efficient and affordable water and wastewater treatment technology. We do have very good technologies now available, but are they affordable or not? That's a big question mark. And that is where I have been advocating many times, that natural ecosystem are the ones which can actually do a lot of treatment. Now, even in climate change negotiation, these words have started coming in. We call it nature-based solutions. So nature-based solutions are nothing but using wetlands to do the treatment, and wetlands can actually do water purification as well. I'm not saying it's applicable everywhere, but there are places where it has been successfully implemented, and it can be looked at from that point of view. Improved treatment methodology of surface and groundwater. Now, any treatment methodology that we have, that we use right now, one has to look at how do we do it in a specific area with local resources, and that's where the research is required. Otherwise, we do have all the information, which is important. Assist local bodies in building capacity to reduce health vulnerability and climate change, and in this, water plays a bigger role. Bigger cities do have systems in place, but academic institutions which are located in those areas or areas where there is nobody else, I think we need to work there very closely with them. Lastly, drinking water units should be efficient and affordable. People should be trained to install technology suited for their own houses. And why I'm saying this is, in the era of Kent purifier or any other purifier which is there in market, even if you add all that numbers together, it is not even covering 2 to 3% of our population. I'm taking a very holistic and big view. But what happens to 95 to 97% of our population, which simply cannot afford, or possibly they don't even know how this technology works? And that's where the research is required, that how at household level we could develop something which can be built your own treatment system, so that what we drink is safe enough for all of us to survive. So thank you very much again, all the SOCLEEN members. I'm honored to be there with all of you today.
So you got still lots of time to left. Almost 18 minutes. We can have some question answers.
Yes.
Participants, can we have some question answers?
Yeah, he said yes. So
Yeah. I'm asking for the participants.
I wanted it to be short. I had indicated that
yes.
So primarily, I would also say that all the SOCLEEN members and those who have joined today, if we can form small groups in different areas of our society or place where we live, and then impart whatever basic knowledges which are there. When we say basic knowledge, does not mean that we start becoming preachers, but we basically go and demonstrate that this is what works, and it works because of falling reaches. So that's the message that we can take on World Water Day today.
Yes.
So just
Rakesh Kumar, I have Tushar, can I ask? Go ahead.
Yeah, yes, sir.
Yeah, because it could be a very funny question, probably. See, groundwater, we depend on so much drinking to irrigation to that industries, particularly. As I said in the morning, 1/3 of the groundwater goes for industries. Now, when we talk of recycle and reuse of water, that is what we are expecting from the corporations, that an organized sector, that water use network distribution. So we can also think of recycling, reuse of water, and we're putting mandates on the big establishments like hotels and all that. It's fine. But when it comes to industries, you have the experience that most of these industrial zone or industrial pockets, they have been using huge amount of water, but the tendency or problems or ETPs and so much, is to just throw that either sums or CTP on, and many times it is a failure. My question is, can this wastewater as such can be used to recharge the groundwater without a purification? So the soil, will the soil take care of holding the pollutants, and at least to a reasonable extent, so that it can go for other uses, not for drinking purpose. If you are drinking, you want to withdraw that, you have to treat it naturally. But otherwise, instead of sending it to the sea and creeks and estuaries, and of course the rivers, can it be thought of in organized way, at least to recharge that zone, industrial zone for groundwater?
I would answer it in two different ways. There are industrial wastewater, when it is generated, at least depending upon which industry, 40-50% of their wastewater is of low strength wastewater. It's not so polluted. So those possibly can be treated using soil aquifer system, depending upon where the groundwater table is. But rest of them would need intense treatment before they are let on the ground using soil. Because if we do have many bad examples in our country where when we tightened the rules a lot, people pumped their wastewater into the groundwater, which happened in the state of Gujarat and Tamil Nadu and many other places. So I would say it two ways. So low strength wastewater is something which can be done. The other ones we need to be very guarded based on the past experience. You are muted, Dr. Sawant.
I have a question.
Sawant Sahab, आपका mute है.
No. My point was that not industrial chemicals and toxic one, but the other washeries type of industries, agriculture processings, like where the surface soil and pores and other things will take care of filtration, and certainly not the toxic waste and toxic chemical, but rest of the industries, we have the different kind of zones of industries, whether that can be.
So I mean, these are the ones which require a bit of small research and field testing,
Exactly.
and then only one should do it. Yes, absolutely.
I have
Dr. Mahadevan.
Dr. Mahadevan. I have a question to Rakesh Kumar. In my understanding, many of the major industries are using the sewage and treat it and use it for their process water. So quite a large amount of water that is untreated sewage being treated, and your comment on that first one. Second one is, can the sewage water in urban areas be treated with soil percolation as Dr. Sawant raised? Is it feasible? These are my two questions.
On the first one, we do have now enough confidence to use sewage after treatment in process. So RCF is doing, and there are many other industries which have started doing it already. So that's a positive point, and the reason why they are doing it because the cost economics works in their favor. They are able to get the cost of the plant, so-called return on investment in 3 to 5 years. Whereas if you want to do it in household, probably it will be more expensive. But industries are doing it for sewage, absolutely no harm, and that's how it is being done. Soil aquifer treatment has been an area of research for almost now 40-50 years. There were some groundwater based subsoil aquifer treatment which has been done in the state of Gujarat, but it requires very careful monitoring. So depending upon which soil strata and how much the depth of it that we are using, and the length and the strength of the wastewater, it is possible. But as I said, monitoring is a major issue in our country, and therefore, if it is done in a controlled way in particular place, chances are that we could succeed.
Thank you, Rakesh.
Thank you very much.
Sir, I have one question. You said about some using this water, natural resources. You were talking about wetland. So what are other options?
So wetland is one example which I told you can possibly be used for wastewater treatment, particularly when we talk about smaller towns, villages, and other places. I think all the researchers in the domain of environmental science and engineering, they need to relook at our so-called oxidation ponds and facultative lagoons and aerobic lagoons. They just need small improvement, and there is a possibility that with almost zero energy use, we can treat the wastewater to that level what we were doing it by mechanical means. The reason why I'm saying that is that all mechanical treatment plants in our country, even today, 85% of them, they don't function after 2 years. And the reason is operation maintenance cost not being available with local municipal corporation. So industries are able to do it, but somehow all the municipal corporation, which all municipal corporation, very few of them are rich enough. Most of them are not able to pay their own salaries. So you expect them to bear the cost of operation maintenance, including very high electricity cost. We need to rethink in this direction. And we should put our mind together and work it out. It's possible.
Thank you, sir.
Thank you.
So can you throw on some light on this the Indian subcontinent, the aquifers? How much water is there in Indian subcontinent or in India, that aquifer water we have? Because we have a system of groundwater exploration for every purpose, drinking. We have surface water connection, dams, collection, dams and all that, bringing water to that. Anyway, that cycle is there on. But suppose the aquifers are enough in this country, and now this kind of the theme now that invisible make it visible, will it reduce the pressure on surface water collections, the dams for drinking purpose, irrigation purpose? And these aquifers, once you read, we have huge rainfall. They can be modeled to recharge them, and cycle that water. So I have not heard of any kind of this work that we are concentrating on measuring the volume of aquifers. We have so many techniques, tracer techniques can be used, and the mechanism now, the technology for extracting that water and recharging again.
Mhm. So actually, if I can add here, so I may not be able to give complete perspective of the issue that you have raised, but part of it is true that looking at the population that we have and which we will have as we go ahead, uh, groundwater will not be able to solve our problem, or surface water also will not be able to solve our problem. So we have to have judicious mix of these two. And when we say groundwater recharge, all the time when we say rainwater recharge, it normally recharges the, I would say, the upper aquifer, not the deeper aquifer. But problem is that now we have started abstracting from deeper aquifer. They take much longer time to recharge. So there we will need a very different game of probably using the fractures and then recharging them on a longer term basis, which is what Australia is doing in some of their states where they call it water banking. So they know how much water has gone inside and how much they have abstracted in a particular season. So it's exactly like the way we operate our bank account, how much we have deposited and how much we are taking it out. But that has to be done in a very professional and under strict control measurements. I mean, that's the limited knowledge that I have about groundwater management, which I thought I'll share with you.
Tushar, we're happy to see that RC Jain, he was very busy in early program, and I can see him now. So his lecture is at, you can start with that. I can see him. There are no questions to Rakesh Kumar, and we had enough questions and we grilled him enough, bothered him enough, so it can be relieved and we can catch him again in 2:30 bit session where he's going to make some announcements also. So welcome, RC Jain, sir.
Dr. Sawant, I raised my hand.
Okay.
So can I ask you?
Sure.
Okay. So I'm not asking questions, but whatever Rakesh Kumar he said, and whatever Sawant you said, okay. So I would like to say that the first thing is about the treatment plant. Because of the money, we cannot afford. I was at IIT Kanpur for 23 years. And now I'm in California right now. In California, we have a very good treatment plant in Orange County. Okay. And we are drinking almost sewage water, and which is well treated. And they examine the water, the 300 parameters. Okay. They do it, and then they distribute the water. Okay, can we afford in India? Why not in the major cities? We should do that. Okay, so in Kanpur there is a treatment plant, but in the monsoon season there is a leakage of water. The old pipes are there. Okay, it becomes very, very difficult. The second point I want to discuss about the aquifer, whatever Dr. Sawant he said, the real problem and challenge in the future about the groundwater aquifer. In the whole of the Indo-Gangetic Plain, in 60s, okay, we were tapping water and we started sowing rice, and the rice we are producing also in Punjab. Okay, for the rice we are tapping groundwater, and our groundwater is depleting from west to east. Okay, so this is going to be really a problem, and then I'm sure the Honorable Prime Minister Modi is going to think over, and he always raised the question of the groundwater. Okay, so if I see in Punjab, and in Punjab, groundwater is depleting, and but we should bring out the law so that the rice, we should not, we should change the cultivation. And I belong to Eastern UP, and I remember in 60s, we were not producing rice in our village. And then when water was available, we started producing rice. Okay. And the same thing in Punjab. And after the rice, we produce wheat. Okay. And there is a serious problem in Punjab. The problem is the crop residue burning. The water is depleting. Okay. In a whole of and when I see Banaras, I'm from Banaras, and Banaras during summertime, the groundwater depletes, and our own house water pump stopped working. Okay, and there is a serious problem, and the problem also related with the quality of water. Okay. So we have to think over, and I'm very happy that today you are celebrating the Water Day, and there are the other places the Water Day is being celebrated. Okay, so we have to we have to tell people, population, we have to save the water. Okay, so these are the problems, you see, and the problems. The question is whether we can sustain the water, okay, in future, because we are polluting the atmosphere, and we are not getting water. Our groundwater is not getting recharged. The problem exists in Rajasthan. Problem exists in Punjab. Problem exists in the whole of the Indo-Gangetic Plain. So thank you very much for giving me a chance to express my
Thank you,
views.
sir. Thank you.
Okay.
Thank you.
Thank you.
I think
And
very
so we
rightly
move on.
said, Dr. Singh, you made it a very good point, because the cropping habits have changed due to high water availability, and that has created more issues. So it's a bit philosophical, but it's important to address this, and that's where the traction of all the people who are knowledgeable should come in. You know, people should share and talk about it multiple times. Punjab never used to grow so much of rice, which it is doing now. It used to be only wheat.
Right.
Yeah, absolutely. Thank you for sharing your thoughts. That's very nice.
Thank you.
Thank you. So we move on to the next topic, and we have a eminent speaker, Dr. R.C. Jain, who's going to talk about very lovely topic here, whether it is a
Is the hand. Ramesh, you have some more question? Ramesh Singh? Your hand is still raised.
Yeah. Thank you.
No, okay. Okay. Tushar, please go ahead.
it's time up, yeah.
Welcome, Marcy.
So I request Dr. Shashirika here to introduce Dr. R.C. Jain, who's going to talking whether it is a water or water management. Okay. Over to Shashirika.
Yeah, thank you, Tushar. It's my privilege to introduce Dr. R.C. Jain. Dr. R.C. Jain is a former chairman of Central Groundwater Board and Central Groundwater Authority under the Ministry of Jal Shakti, Government of India. He has obtained his master's degree from IIT Roorkee and PhD on integrated water resource management from the University of Rajasthan, Jaipur. He has authored more than 35 papers in international and national peer-reviewed journals, and delivered more than 100 lectures and keynote address in national and international seminars and workshops. He has spearheaded the National Aquifer Mapping and Management Program, and the largest groundwater mapping endeavor in the world, as national coordinator and standardized protocols for diverse hydrological environments in the country. Besides this, Dr. Jain has also conducted expert courses for UNESCO, IITs, and NGOs for groundwater management and managed aquifer recharge. He has professionally trained He is professionally trained from the Institute of Hydraulic and Environmental Engineering, Delft, the Netherlands, the United States Geological Survey, National Geographic Research Institute, Indian Space Research Organization, National Institute of Financial Management, Indian Institute of Public Administration, etc. He was the chairman for the Water Resource Divisional Committee on Groundwater, Bureau of Indian Standards, that's BIS, for formulation of Indian standards in groundwater sector. He is a recipient of Award of Excellence in Groundwater Management, conferred by the Indian chapter of International Association of Hydrogeologists in 2019. Dr. R.C. Jain has also rendered his expert services to the National Water Mission during 2015-16. Presently, his services are retained by the government of Gujarat as advisor to the government, to the Gujarat Water Resource Development Corporation, Narmada, Water Resources, Water Supply and Kalpsar Department of Government of Gujarat since 2016. I believe he's the right person to speak on the topic that he has chosen to talk on today, is that scarcity of water or scarcity of management in India. Over to you, sir. Dr. Jain.
Good afternoon. Thank you for the introduction. Can I have the screen?
Yes, Sakina.
Press the green button in the middle. Screen sharing. Then green button dabao screen sharing ka.
So you are co-host now. You can.
You are co. You can share it yourself. Yeah.
Share the screen. Green button in the middle at the bottom. At the bottom line, green share screen.
Yes.
Press that.
Yes, I am doing it. Okay, is the PPT visible?
Yeah.
Yes, sir.
Yeah.
Yes.
Okay, fine.
If you can enlarge it.
Yes, I'm doing it. I'm just doing it. Is it okay?
Yes.
Okay.
Yes.
Okay. Fine. Thank you. So the subject of my talk is scarcity of water, scarcity of management in India. Basically, we do not have a scarcity of water in India, but a scarcity of management. And this is the major cause of scarcity is the mismanagement, and unfortunately, this abounds across the country. In the country, I believe there is plenty of water and also plenty of financial resources. The question is whether we are adequately managing our natural, financial, and human resources so that water flows to the places it is most needed. Water scarcity, as everybody understands, we had the availability of more than 5,000 cubic meters per capita per year at the beginning of the at the time of independence, sometimes in 1951, which is now reduced to about 1545 cubic meters per capita per year in the year 2011, and it will reduce to about 1350 cubic meters per capita per year in the year 2021. It has already reduced. So we are reaching a situation of water scarcity. As per the Fallen Mark water stress indicator, an area is considered as water stressed when the annual water supply drops below 1700 cubic meters per person. And when it drops below 1000 cubic meters per person, the population faces water scarcity. So that situation is foreseen in the future. Now, this water shortage in India is basically both a natural and a human-made phenomenon. There is enough fresh water in the country, but the issue is it is distributed unevenly and too much of it is wasted, polluted and unsustainably managed. Water use is expected to continue increasing as a function of population growth, also economic development and changing consumption patterns and other factors. So now let us have a look at the India's water resources. We have nearly 17.5% of the global population, but only 4% of the total water resources. If you look at the estimated average annual precipitation in the country, including snowfall, it is about 4,000 billion cubic meters. But the average annual potential in the rivers and aquifers is assessed to be about 1870 billion cubic meters because of evaporation and other losses. Out of this 1870 also, the estimated utilizable potential is only 1122 billion cubic meters because of the topography and other distribution losses. So we have a breakup of about 700 billion cubic meters in surface water and about 430 BCM of groundwater. Per capita availability as per census 2011 was 1545 cubic meters, as I said. And the per capita storage works out to be about 208 cubic meters per day. The estimated utilization is of the order of about 700 BCM, taking surface and groundwater together. So the factors, let us look at the factors which influence the water scarcity. They are social, institutional and policy arrangements, lifestyles and water quality. And the main factors affecting water scarcity in India are regional climatic disparities, diversified hydrogeological conditions, underutilization of irrigation potential created, over-exploitation and virtual water export, overpopulation and water pollution. Now we will be discussing each one in a little detail. So if you look at the regional climatic disparities, as I have said that only 1120 BCM is utilizable only because of the topographic constants and distribution effects. The changes in temperature and precipitation, they have basically affected the regional water resources and the flood risk, exacerbating regional disparities in water availability across the country. Though we receive about 115 centimeters of rainfall every year, but because of the spatial variations, there are differences in the availability. And again, the problem is we don't receive this rainfall throughout the year. It is more than 80% of the rainfall is received mainly during the southwest monsoon season. And then only in Tamil Nadu, the rainfall is in October, December, while Jammu and Kashmir, Himachal Pradesh, Uttarakhand, they receive rainfall all the 4 times a year, all the 4 seasons. So the significant precipitation occurring over a short period, as I said, between June and September, results in a high volume of runoff and consequential floods. However, acute shortages are common in many regions during the rest of the year. Even many of the Indian cities and towns often run out of water during summer due to absence of sufficient surface water systems and infrastructure, leaving groundwater as the only feasible source. Now, if you look at the distribution of rainfall, you can see that it ranges from less than 10 centimeters in the western part of Rajasthan and Gujarat to more than 1,500 mm in the northeastern region, and also quite high in the central, in the coastal western coastal areas also. But the distribution, if you look at the distribution, then only 4 months have a significant rainfall from June to September, as you can see from the graph. Now, if you look at the host rock of the groundwater, basically the aquifers, India has got a very diversified system of aquifers. All the different rock types have been classified into basically 14 principal aquifers. And based on the water bearing characteristics, of understanding the hydrogeology of the country. So the alluvium, which is shown in different shades of blue in the map on the right side, is basically covering 31% of the area, and it is the most productive aquifer found in the northern part of India, forming a belt right from Punjab right up to Uttar Pradesh, going through Bihar and West Bengal, and also the Brahmaputra Valley. They form the most productive aquifers. excepting some isolated alluvial patches in different parts of the country. The second most important aquifers are the basalts, which cover nearly 17% of the country's area. They are shown in green color in the principal aquifer map on the left-hand side. And there are suite of hard rocks, excepting the basalt. Everything in the south, basically, is the suite of hard rocks, which is occupying nearly 43% of the area. And then there are some semi-consolidated formations also. So yield-wise, alluvium gives yields in the range of about 5 to 20 liters per second. Basalts, anything between 2 and 10 liters per second. In hard rock areas, except most favorable locales, we may get yields up to 3 to 4 liters per second and semi-consolidated about 5 liters per second. This is the potential. And this potential is because of the storage and transmission characteristics reflected in terms of the storativity and the transmissibility of the aquifers. If you look at the second important aspect is the underutilization of the irrigation potential. In India, the total cultivable area is about 186 million hectares, but the net sown area is about 143 million hectares, of which if you look at the utilization which is possible, then from major and medium irrigation projects, that is surface water, ultimate irrigation potential is about 60 million hectares, and created potential is about 50 million hectares, and utilized is only 34.5. So there is a gap between irrigation potential created and utilized of the order of 13.4 million hectares, which is as high as 28%. In case of minor and surface groundwater structures, ultimate irrigation potential being of the order of 80 million hectares, already created is about 65 million hectares and utilized 52. So here also the gap is about 20%. It is comparatively less. So what is happening is millions of liters of water is lying unused in the command areas of large dams in India. We should actually reach the farmers for whom it is meant. These dams were basically built at a huge financial, social, and environmental cost, but they have not yet fulfilled their promise because they have not been able to deliver to the promised areas because of the non-existence of canal area development works. Our focus has been basically on building more and more dams and not on putting in place last mile connectivity to ensure that the water reaches on the farm. The third factor is the overexploitation of the water resources. As you can see, India is the largest extractor of groundwater in the world. It extracts more than the combined withdrawal of US and China. It's about 250 BCM, million cubic meters per year. As per the assessment of the stage of development carried out by the Central Groundwater Board in association with the states, this assessment has been carried out on a block-wise basis. And there are 6,965 blocks in the country. But you can see that there are already 1114 overexploited blocks. Overexploited basically means the groundwater draft in these blocks exceeds the annual replenishable recharge. So we are into the negative. Then 270 are the critical blocks where the draft is about between 90 and 100% of the recharge. So these are all this critical and overexploited make something like 1400 blocks. So more than 20% of the area of the country is basically in a very critical situation. And Delhi, Haryana, Punjab, and Rajasthan, they extract more than 100%, mostly overexploited. And while Himachal Pradesh, Tamil Nadu, UP, and Chandigarh, they extract something between 70 to 100%. So they are also in a critical to semi-critical stage. The overexploitation is mostly concentrated in the northwestern part of the country, Punjab, Haryana, Delhi, and western part. There the replenishable resources are abundant, but there is indiscriminate withdrawal of groundwater leading to overexploitation. In the western part of the country, particularly parts of Rajasthan and Gujarat, it is the arid climate. The groundwater recharge itself is limited, leading to stress on the resource. And in the southern peninsula, as I said, including parts of Karnataka, Andhra, Telangana, Tamil Nadu, etc., due to inherent aquifer properties, inherently low storage and transmission properties of the crystalline aquifer, the groundwater availability is very low. Then you see we have about 20 million wells extracting water with free and subsidized power supply. This is very important. And then 89% of the water extracted from groundwater is consumed by agriculture. Then the virtual water export. One of the speakers was making a brief mention of it. So India is reported the top net exporter of virtual water in the world. See, we are having over exploitation, but still we are, one of the top net exporter of virtual water. We are exporting something like 100 billion cubic meters of fresh water through crops, animals, and industrial products. And this may not look huge, but consider the fact that the extraction is highly localized, especially in the northwestern part of the country, Punjab and Haryana. This probably does not improve the water rendered unsuitable through contamination during production of the crops. A lot of fertilizer and pesticide applications that contributes to a lot of pollution also. So can a country like India, which is deficit in water resources, afford to export it unless we reduce the water footprint significantly? Then if we take the example of rice, India is the second largest producer of rice in the world, about 116 million metric tons. In the year 2018-19, we exported about 12 million metric tons, basmati and non-basmati, considering about 3,500 liters per kilogram. The total water exported is about 42 BCM. The water footprint of rice exported alone accounts for 36% of the total groundwater extraction of the top 5 rice producing states: West Bengal, UP, AP, Punjab, and Tamil Nadu. And similar is the story about other exports like sugar, cotton products, cotton, machinery, etc. Then there is another factor which is causing the problem is the overpopulation. Population growth is causing tremendous pressure on the water supply. And India is second most populous country in the world. All of you know that we are something like 1.38 billion people in the country, and increased life expectancy and other factors contribute to rising population and overcrowding in many areas. In addition to this, due to various socio-economic factors, there is very large influx from rural to urban areas, resulting into poor development, poor planning, and loss of ecosystems and diversity. Basically, this rapid urbanization has led to an increase in the local urban flooding due to increase in the paved areas and decrease in reservoir capacity, drainage, and space for recharge areas. So as the population continues to grow and migration of population in already water-stressed urban centers continues, demands of water will put additional strains on water allocated for freshwater resources. Then there are problems of water pollution. Basically, we have got two kinds of issues: the non-point sources and the point sources. The non-point sources, basically, these are the fertilizers and the pesticides in the farms. And the point sources include industrial and human waste, which is a significant amount directly dumped into the rivers without treatment. So the largest source of pollution in India are basically the untreated sewage and partially treated industrial effluents, which also have seeped underground, polluting the groundwater in some areas. The untreated urban water is often discharged to streams, affecting downstream water quality and causing health problems. And during summer months, with low flow conditions, the contaminated discharge also reaches high levels. So this is so far as the issues which were affecting the supplies and causing the scarcity of water. If you look at the actual demand scenario, as projected by the National Commission on Integrated Water Resource Development, we see that the demand is increasing from 710 in the year 2010 to 843 and ultimately to 1150 BCM in the year 2050, wherein we would have already bypassed the average annual water availability of 1122 BCM. Now, water management in India, basically the issues are, it is heavily dominated by the human-built infrastructure, but the enormous potential for working with the nature has remained underused in India. So the need is, there is a paradigm shift which is required in management of approaches towards water shortage challenges in India through progressively increasing use of nature-based solutions across all sectors, including water needed for agriculture, sustainable cities, disaster risk reduction, and water quality. The nature-based solutions can together play a big role in better water infrastructure through conservation. For the sake of example, the harnessing of the opportunities for hydrological cycle with rainwater harvesting, stormwater management, and so on, and the grey infrastructure upgrades that is improving the operations of water distribution infrastructure. The water management situation in the country requires a paradigm shift, as I said, from strictly conservative approach to increasingly more green nature-based solutions and a mix of other specific technical and policy interventions like increasing water use efficiency, addressing water energy nexus, and regulatory measures for controlling human interventions and behavior with institutional response to natural phenomena. So then you see how we are going to really look at it. So of late, the dialogue on water and the environment has significantly shifted towards the ways in which the environment can not only be conserved, but manage to meet human needs sustainably with a focus on working with nature to produce co-benefits both for the people and the nature. And the nature-based solutions for water have contributed importantly in this dialogue. The option of building more surface water reservoirs is increasingly limited by uncertain precipitation, reservoir siltation, environmental concerns, and the fact that most cost-effective and viable sites have already been used. In addition, increasing temperatures lead to increased water loss through evaporation. So as a part of this shift, groundwater and the subsurface environments that contain it, that is the aquifers, are increasingly seen as strategic and integral resources for enhancing water supplies and other natural ecosystem services that support the human development and resilience. Hence, it is increasingly important to enhance, manage, and sustain services derived from nature-based infrastructure of aquifers, nature-based infrastructure of aquifers through underground, through managed aquifer recharge by managing and optimizing underground water storage to increase resilience in dry periods. Next. So the green and gray infrastructure, basically, what is it? The green infrastructure approach uses natural processes to enhance water availability, that is soil moisture retention, artificial groundwater recharge, improve groundwater availability through natural constructed wetlands, riparian buffer strips, and reduce the risk associated with water-related disaster and climate change, like for floodplain restoration and green roofs. The green infrastructure actually expands the low-impact development approach to a larger community scale and presents similar sustainable opportunities to local governments and regional projects. To develop a sustainable water supply scenario in India, the green infrastructure approach can substitute, augment, or work in parallel with the gray infrastructure in a cost-effective manner. So both the kinds of solutions, the nature-based solutions for conservation and also for the gray infrastructure upgrade, can together play a big role in better water infrastructure for India. The nature-based solutions mainly address water supply through managing precipitation, humidity and water storage, infiltration and transmission, so that improvements are made in the location, timing and quantity of water available for human needs. This is the requirement actually. So to assess the potential of managed aquifer recharge in the country, the Central Groundwater Board in the Ministry of Jal Shakti has carried out a mapping of the areas in the country which are suitable for artificial recharge, and has also demarcated the priority areas based on the stage of development, which are shown in shades of pink, red, and green. So the areas suitable are about 11 lakh square kilometers, where the depth to water level is more than 3 to 8 meters with declining trend and with the water quality deterioration. The volume of non-committed surplus water which is available for recharge has been estimated at about 185 billion cubic meters, and potential for augmentation of recharge exists for 130 billion cubic meters of water. The estimated cost of implementing this plan is about 1,33,145 crores. Now let us look at the gray infrastructure, human-built infrastructure, what can be done. So it is necessary here to undertake a campaign, in a campaign mode, a program to close the gap between irrigation potential created and utilized, which is of the order of 28%, through farmer participatory canal area development works. Aggressive promotion of participatory irrigation management through WUS at the outlet and distributory level is absolutely essential. Further, the establishment of minimum irrigation service fee at a reasonable level has to be considered, and 50% of this should be provided for maintenance and distribution to the WUS to have a participatory irrigation management. And further enhancing the resources available to major and medium irrigation departments for improving O&M of the irrigation systems through technology improvements which are taken place, and automation and use of information technology like SCADA. This is also very important. Then we also have to substantially improve the amount and quality of training and capacity building opportunities for this irrigation staff at all the levels. So if we look at the opportunity for improvement of the water use efficiency in India, see, these are the numbers worked out by the National Commission on Water Resources Development. In the irrigation sector, in surface water, the first column shows the quantity of water being used. This is about 339 BCM, and the present level of efficiency is 30%. The full achievable efficiency is 60%. So there is a scope for the 30% increase in the efficiency. And the quantum of water which is likely to be saved is of the order of 102 BCM. You know, this is a tremendous quantity. And if we increase the efficiency only by 20%, still we save some 68% of water. And so also for groundwater, there also the level of efficiency is about 55%, which can be increased by about 20% to 75%, and we save about 44 BCM of water. In the drinking water sector also, there is a lot of non-revenue water and other losses. So we are achieving an efficiency of 60%, but it can be taken to 90%. And there are technological solutions which are available, and we save another 10 BCM. Similarly for industries and other aspects also. So this is the scope for saving. So we are able to save something like 130 BCM of water. And at the 20% efficiency from the current level of inefficient use. And the total, if we achieve the projected efficiency at the full achievable level, we are able to save something like 170 BCM of water. So if we look at the water use efficiency in the irrigation sector, which is using something like 89% of the all groundwater pumped and more than 70% of the total water resources of the country, there is a lot of there is lot of scope in improving the efficiency, because in the traditional irrigation techniques through flooding of the fields, significant water loss from evaporation takes place, and then there are other losses like drainage, percolation, water conveyance, etc. The potential solutions are to educate the farmers on best practices, including micro irrigation techniques such as drip and sprinkler and precision irrigation. So even with 10% increase in the water use irrigation in the projects, about 14 million hectares of area can be brought under irrigation. As per the estimates of the National Water Commission, about 112 BCM of water could be saved, as I said before. That could meet the additional demand for irrigated agriculture projected for 2050. The present use efficiency, surface water is 35-40%, groundwater is 65-70%, and there are deficiencies in the water delivery systems, inefficient water management in the fields. The next, now let us look at the non-revenue water, the losses in the drinking water network. The amount of non-revenue water is high for several reasons, including advanced system age, poor maintenance, illegal connections, leakage, and lack of proper mapping. And average NRW in India is almost 32% as per the studies carried out by ADB and Ministry of Water Resources. Even in some of the Indian cities, NRW is more than half of the water produced. The major determinants of water utilities' successful performance are mainly lack of metered connections and the extent of distribution networks with inadequate pumping facilities. It is estimated that the Indian municipality water utilities have the potential to improve water pumping system by about 25%, thereby increasing the supply reliability. Better water accounting would support more economically viable water markets. For an already stressed water sector, and to this end, the creation of a robust water accounting framework is integral to a better water policy for India. Such policies as providing free electricity to the farmers or giving financial support for groundwater extraction have resulted into uncontrolled exploitation and the waste of the resources. Now let us look at the wastewater segment. The reuse of treated wastewater could be an effective instrument for strengthening the financial position of the municipalities. It would also help in addressing the problem of domestic water pollution. Further, India should give emphasis on developing 100% treatment capacity up to the secondary level of treatment. Treated water can be used for irrigation purposes and industrial purposes. And industry should be mandated to reuse treated municipal wastewater. States like Gujarat, Maharashtra, and Tamil Nadu have already taken measures in this regard. Revenue obtained from the sales of the treated water could be used to supplement the sewage treatment costs, which are also quite high. Then India is yet to define actually the discharge standards for agriculture water pollution. That is also to be, this is a deficiency. Corrections in fertilizer and pesticide and electricity pricing policies could be an instrument for addressing the non-point source of pollution in India. Then we have got the poor quality groundwaters, which are brackish and saline, but they can be used to produce many crops, vegetables and fruits like barley, dates, and pomegranate. Even if they are irrigated with saline or brackish water, their yields are not significantly affected. It is most of the poor quality groundwater resources in India are basically confined to the states of Haryana, Punjab, Delhi, Rajasthan, Gujarat, Uttar Pradesh, Karnataka, and Tamil Nadu, and the inland groundwater potential is about more than 1100 BCM, which is only partially used now. In addition to use of this resource, we can also have dual water supply system in urban settlements where fresh treated water is provided only for drinking water supply and the brackish groundwater for other domestic uses. The use of this resource will help in save fresh or good quality water for use by other sensitive crops. Then another important aspect is the intelligent management of energy irrigation nexus. So managing the energy irrigation nexus with sensitivity and intelligence is the principal tool for groundwater management. Tariff report has proved to be a political challenge in many of the states, but other hybrid solutions have been invented. Like Gujarat has the experience of the Jyotigram scheme, under which the irrigation and domestic power supply lines have been separated. The irrigation sector gets 8 hours of committed three-phase electricity every 24 hours, and the domestic sector gets 24 hours. That way, we are able to control the groundwater withdrawal. But in other states of the country also, for demand management, certain actions have been taken, like Punjab has effectively introduced stringent power rationing in summer to encourage farmers to delay rice plantation by a month, and in the process, significantly reduce groundwater depletion. In Andhra, farmers get free power, but now they have imposed a 7-hour ration. So this will also reduce the groundwater withdrawal. Haryana has introduced higher MSP for less water intensive crops, thus reducing electricity demand and also reducing on groundwater depletion. Then we have the regulatory framework, both in the National Water Policy and in the draft National Water Framework Bill, which basically addresses the planning, development, and management through local, regional, and the national context, providing for safe water for drinking and sanitation on top priority, and bringing maximum efficiency in use of water and avoiding wastages. At the same time, we have got a national water framework prepared in 2016, where states will hold water in public trust, and an independent statutory water regulatory authority will be created for integrated water resources planning with river basin as a hydrological unit to protect hydro-ecological integrity and allocation and pricing on economic principles. And further, the management will be implemented through the participatory approach, and regulation of groundwater will be on the principles of non-discrimination, equity, and subsidiarity. And both the surface and groundwater have to be managed conjunctively. For groundwater, because there are a lot of stress areas which are emerging, the Ministry of Water Resources has circulated a model bill where the groundwater is treated as a common resource, common pool resource, as the heritage of the people held in public trust. And in natural state, groundwater is not amenable to ownership by any of the state, communities, or individuals. The bill follows the principle of subsidiarity, ensuring the participation of lowest level of decision making. And this framework will ensure availability of groundwater for livelihood, in effect ensuring that overwhelming majority of small farmers will have water available for their crops, resulting in effective regulation of the large-scale groundwater use. The bill recognizes that groundwater is perhaps the single most important resource governing India's future economic development and life and livelihood security of the Indian people. So far, about 18 states in the country have implemented groundwater regulation. Then what is more smart planning also plays an important part in achieving the goals of sustainability. To achieve some of these goals, India has started planning and developing a few cities, initially with 20 smart cities identified in 2016 in the vacant lands. Later on, this number has increased to 100. These smart cities represent comprehensive development in terms of institutional, physical, social, and economic infrastructure to reduce congestion, air pollution, and resource depletion, boost local economies, promote interactions, build computer-aided efficient transport systems, and water infrastructure, and ensure water security. The main idea behind the smart city concept is to promote mixed land use in area-based development planning, as it were for unplanned areas containing a range of compatible activities and land uses close to one another to make land use more efficient. Now, I have just, in this slide summarized, what is the kind of impact which will have if we implement the water management interventions which are already known. The first and the most important is the aggressive promotion of efficient water management practices in all sectors with emphasis on agriculture sector. The potential for saving is about 110 BCM. Then nature-based green infrastructure of aquifers, we can save about 185 BCM of water in the underground aquifers where potential exists. About 1000 BCM of more than 1000 BCM of brackish and saline water. Grey infrastructure improvement to minimize the non-revenue water is expected to contribute about 10 BCM, and the sewage effluent treatment, etc., another 10 BCM. So the impact is generation of about 3000 BCM of fresh water through 1 and 2 efficient water management practices and green infrastructure for aquifer storage. And also we have additional 26 million hectares of irrigation potential by closing the gap between potential created and potential utilized. So, and then in addition to this, we have the enabling regulatory framework for water allocation and utilization with institutional framework for effective enforcement. The additional revenue generation of the order of 47.6 billion rupees and for 2.38 BCM of groundwater alone used for industry at the rate of 20 per cubic meter. This is something like 50 billion rupees. We will generate additional revenue which can be utilized for the development and management purposes, capacity building, awareness, incentive, and for efficient water use. So, adaptation and resilience is basically the mantra. In many regions of India, the water supply scenario is variable. And India is not a water deficient country in general, but from neglect or lack of proper management, several regions in the country experience water stress from time to time. The country needs to implement water management strategies that are adaptive and resilient because it faces an uncertain water future as a result of climate variability and social changes. So India needs to make it a priority that significant investments be allocated in green nature-based solutions, improving grey infrastructure and regulatory institutions for sustainable development. The nation's water policy should ultimately integrate under the one water concept to support social, environmental, and economic needs for under sustainable way. The better management of water systems with blended green and grey infrastructure solutions, efficient use of water in irrigation, domestic and industrial use, and restoration and protection of water resources are the keys to India's social development going forward. So ultimately, we come to what are the ways forward. The first and important one is the closing the gap between IPC and IPU. It is also a low-hanging fruit, which can be picked by investing in CAD works, ERM projects, and irrigation management reforms. The second most important thing is the improving the efficiency through aggressive promotion of incentivization of sprinkler and drip irrigation practices on a massive scale in general. It can be the most important demand side management practice. Then the supply side augmentation, the managed aquifer recharge, it offers the best opportunities for storing the water which otherwise goes unutilized. The precipitation 180 BCM, that's a tremendous amount. So through managed aquifer recharge, because managed aquifer recharge is the most economic, most benign, most resilient, and most socially acceptable solution. But in India, it has not been given due importance in the past due to lack of awareness, inadequate knowledge of aquifers, immature perception of risk, and inadequate policies for integrated water management, including linking managed aquifer recharge with demand management. Then we should also have we should also mandate progressively increased use of recycled and treated wastewater. This has huge potential for substitution of fresh groundwater used in industrial, domestic, non-potable and agriculture sectors. We should also encourage the use of brackish saline water for selected agricultural crops in western and northwestern India, where huge potential exists. Then in the country, conjunctive management of rain, surface water, treated wastewater, and groundwater is a big, hitherto underexploited opportunity for supply side management. Enabling legislation for sustainable water management and institutions for water governance needs to be established in the states for enforcing effective governance. So what is needed is a change in the perspective. Groundwater offers climate resilient fresh water source and alternate for drought proofing. But evidently, the abstraction cannot ignore the limits defined by the nature. Its exploitation and management requires paradigm change in our approach to ensure sustainability of water resources in India. There is an urgent need to adopt a balanced supply and demand side management interventions. And there's the need to synergize the efforts by all the concerned organizations, communities, people, CBOs, and all other organizations. Thank you.
Thank you, sir.
Thank you, sir.
Very in-depth, and as the nutshell you said, perspective needs to be changed. So the management change, then the whole shortage, scarcity will not be there.
Yes.
Any questions? We got one question by Mr. T.N. Mahadevan. How can we discharge the confined groundwater in arid zones and in rain shadow region apart from normal unconfirmed ones for charging dug wells? Summer high temperatures, evaporation losses in these areas are very high. Your views apart from large scale afforestation?
Yes. So actually, it is possible to recharge the deeper confined aquifers, which have water, which held groundwater under pressure through the injection well techniques, which have been well developed in India, and we have successfully implemented through some of the pilot projects in the state of Gujarat under a United Nations development funding. In the most overexploited Mehsana district, where the deeper aquifers are exploited to the extent of 150%, we are successfully able to transfer the surplus runoff. This is one important aspect I would like to say. And then the second is, hello, am I audible?
Yes, sir.
Okay. So then the second aspect is in respect of the various types of interventions which need to be basically this irrigation potential created and utilized. There is a massive gap actually. So we need to have a change in the mindset of just having the construction and civil works only, but not reaching the water to the last mile connectivity. If the CAD works are taken pari passu with the construction of the civil structures, I think such a gap can be minimized. Then the third point is there is a very large for not only recharging the unconfined aquifer, shallow aquifer, which you say through the dug wells, but also there are several other methods which are available, and a manual on the artificial recharge methods applicable in India in various geological and hydrogeological terrains is available on the website of CGWB. Everybody can have a look at it. I think this describes in great detail the kind of methods, their applicability and technical requirements. I think this basically addresses the question raised by Mr. Mahadeva.
Dr. Jain, I am still not convinced with your answer, because is it geomorphology or geology in arid zone which is causing the problem of water shortage in Rajasthan? I'm talking of arid zone.
Okay, actually there basically it is the less of precipitation. Is the arid zones, because they receive very less precipitation, so that is itself a major reason for low water availability. And so far as the aquifers are concerned, in the arid zone we have got extensive aquifers, so they are capable of holding water underground. But the only thing is that we need to identify surplus water sources. Recently, some activity has been done in Rajasthan. They have identified some amount of water which can be diverted from Indira Gandhi Nahar Canal Pariyojana, because some of the waters which are laid out, that creates problem of water logging in the Rajasthan Canal area, command area. And then if this water can be, diverted through the appropriate techniques, appropriate technology of injection wells or the regular, gravity head wells in the aquifers, which are so-called thirsty aquifers because they lack in the availability of water, we will be able to resolve the problem. But we need to have a source of water. IGNP could be possibly one source of water which could help in augmenting the groundwater availability, especially in the arid regions, because the direct input of rainfall precipitation into the aquifer is comparatively less as compared to the alluvial areas.
Thank you, sir. Thank you very much. Thank you.
Okay, you are welcome, sir.
We got Mr. Dhaval Pandya. You have raised your hand. You can ask a question to Dr. Jain.
Yes.
Unmute, Mr. Pandya, unmute yourself.
Yeah. Hello, sir.
Yes.
Good afternoon.
Good
Sir, we are working tirelessly on converting each water pooling facility into a recharge system, because any water pooling facility can be used as a two-way system. One, you can pull the water. Secondly, you can recharge. Just if India is focusing only on that, I think that can affect somewhere in aquifer recharge and even climate action.
No, I could not get what is your specific question.
Sir, I have written the question in the chat. I'm just reading it for you.
Okay, please.
What can be the effect if we convert each existing water pooling facility into a groundwater recharge system?
Okay. Okay. The reply is both yes and no. No, in the sense that you will have to look at the technical feasibility of the acceptance of water by a concerned aquifer, because you are not looking at a water subsurface water reservoir where you can just transfer water. It depends on the capability of the host rock to accept the quantity of water which you are going to recharge. And the second and most important aspect is the quality of water to be recharged has to conform to the drinking water standards. We do not advocate that any water which is taken out from the aquifer for any purpose should be recharged just like that, because doing that way is basically going to contaminate the drinking water system on which the drinking water system based on the shallow aquifer, on which all the groundwater withdrawals are based.
Sorry to interrupt you, Doctor. So Jain sir, just a second. Others, I request you to mute this. I think Dr. Mahadevan, there's lots of sound, background sound. Others are requested to mute.
Please mute.
Background noise, it seems.
Please mute. Everyone, please mute.
Yes, I think.
Jain sir, you can unmute, please.
That was it.
तुषार देसाई सर, you are mute.
Yeah, sorry. जैन सर, आप अनम्यूट
जैन-
कीजिए. जैन sir, we can't hear you.
It has to be unmuted.
Yeah.
Okay.
Repeat
Am I audible
that, sir.
now? Am I
Yes,
audible
sir.
now, sir?
Yes, sir. Yes.
Okay, so what I'm trying to say is, see, the answer to your question is both no and yes. No, in the sense that you have to look into the technical aspects of the host rock wherein you are going to inject this water. This water injection may sometimes require injection pressure also, and otherwise also the most important aspect is the quality of this water, because many of the contaminants in the water may be passed through the water which you are going to recharge, because we don't have the highest standards for the recharge water in India and elsewhere like the US, Australia and Europe, where I have been visiting these facilities. They have got the specifications of recharge water conforming to the drinking water standards. So if you are able to meet that requirement, you will be basically contaminating the aquifer by recharging any water which you are pulling out from a facility. So the quality aspect needs to be given a greater emphasis, and then the hydrogeology of the area, the transmissivity and the storage capacity of the aquifer. They are other important parameters which should be looked into for the so-called dumping of water. Otherwise, you will have the waterlogging and other related issues.
True. So the systems which are say mentioned on CGWB website, if we follow that recharge structures, we have got the drawings available. The whole system is written on CGWB website, and even with the documents you have published many times. So should we follow that to recharge the existing systems?
These are the basic guidelines, and it does not preclude a hydrogeological investigation to look into the site specific aspects, because area wise, as I have shown in the hydrogeological map also, the geology and the aquifer properties vary a lot, the hydraulic conductivity and transmissivity. So unless you have looked into these issues, just by following a system design, you are not going to have a successful recharge. See, you may be able to recharge some quantity, but it may not be sustainable over a long period of time. So unless this is a pre-feasibility study need to be conducted on the ground to really ensure that this system design works for transferring of water. Basically, the design is for transferring of the water, physical movement of water from the surface to the aquifer. But it does not describe the aquifer properties, that how much water it will accept, what quality of water it will accept, at what rate it will accept, for how long it will accept. So all these things need to be studied in detail before attempting a artificial recharge project. Otherwise, it will bring a discredit to artificial recharge. Then you see recharging the groundwater.
True, sir. As you mentioned about Mehsana, if I'm not wrong. So do we have that data available with us so that we can plan it?
Yes, the Central Groundwater Board, in collaboration with the United Nations Development Program, has carried out pilot recharge experimentation in Mehsana area, for which published reports are available from the Central Groundwater Board.
Right, sir. Thank you, sir.
Okay.
Okay. Thank you, Dr. Jain.
Okay, thank you so much.
For all the person, thank you, sir. Thanks a lot. And now we'll be talking about water, drinking about water.
Here, Vaidya has a question. Ramesh Singh has a question.
Okay.
Why don't you ask them, Vaidya?
Yeah, okay. Am I heard?
Yes, you are audible, Mr. Vaidya.
Yeah, Dr. Jain, you have given a very optimistic statement that there is no scarcity of water, it's still management. But when you look at the figures, 1350 cubic meter per annum per capita, it puts us very close to scarcity. And remember, this is an average figure.
Yes.
Meghalaya to Kutch, I mean, there is a 25 times this year.
Yes.
And no, the irony is this, that we have done nothing. Precipitation is constant, we are increasing. You pointed out that. 45 crore of Indians, 135 crore of Indians, doing nothing, we have reached 1300, and another 10 years, we will reach 1000. Now it's very scary situation.
No, so I have given the suggestions, so I have given the suggestions for different kind of management techniques which should be implemented. because you see, we are not deficient in water resources. I still, hold that view, but we are not managing it. As I said that, through various things which can be practically done, which I have narrated in one of my last few slides. I said that you are capable of generating another 300 BCM of fresh water. Now the 300 BCM of fresh water can account for not only your, the drinking water needs, but also the irrigation needs, which are projected till the year 2050. So the need is for implementing the management practices which are already proven across the world and also implemented in certain parts of India in a isolated manner. So they need to be operationalized on a massive scale. Like say you go for irrigation itself. If you look at irrigation, see you have the straight away saving of 30% of the water resources. If you shift from the conventional utilization, conventional irrigation pattern to say micro, drip and sprinkler. Now where the 30% goes, that 30% goes in making the water available for you. Then in the drinking water sector, I say that you see most of the water we are using in our houses, 80% of it which is not required to the extent of the quality which is being treated and the cost being incurred. The drinking water component out of say whatever prescription from the Ministry of Rural Development or Urban Development, whether 75 liters per capita or 110 liters per capita, the drinking water requirement is not more than 5 to 10 liters out of that. So why should you be supplying the water of drinking water standards of 75 or 110 liters in the rural and urban areas and then allowing it to be wasted in the toilets and the washrooms and giving irrigation to the lawns? Provide the raw quality water, provide the untreated water, nothing is going to happen. So this is the way we are wasting our resources. So I say that whatever water you say in drinking water sector is being made available through augmentation of water supply, 80% of it goes down the drain. You don't require that treatment and that fresh quality of water at all. So this is a total misuse of the precious resource with which we are blessed in India. I think I'm clear about this point.
Yes.
In that context, I would just have a small query
yes.
about irrigations. What is by precision irrigation?
Pardon me?
Precision irrigation. You mentioned the
yes.
word precision
yes.
irrigation.
Mm-hmm. Yes. You would like to know about it? Hello?
Yes, sir. Yes, sir. He's asking what is the precision.
So precision irrigation is basically, you see, we install the soil moisture probes in the irrigation fields to give you an indication of the level at which the crop will start wilting, and only then and then you have to precisely apply the irrigation. So you see, these soil moisture probes are basically linked to a centralized system, either at the farmer's house or in a central laboratory, wherein you keep on getting the continuous signals. And then unless the level of wilting is going to be reaching for a particular crop, you need not irrigate it. So this is a precision irrigation, because our people, basically the farmers, have a tendency to over irrigate and to irrigate more than what is required. And
or flood
irrigation is basically leading to evaporation losses and sometimes into percolation also. But if you apply precision irrigation, as has been already practiced by Punjab Agriculture University and also in Gujarat, we have seen that we are able to save something like 40% of the water applied through.
You got again muted.
No, he's got stuck.
But very precise answer, good answer. I'm happy.
There are again questions coming. So what I suggest, so we take a break, and then we are going to come back again, and there will be awards and the panel discussion. So we take that after the break.
Yeah, you request Jain Saab to be there, and all the speakers. We request all the speakers to be there, because you see how interesting this webinar going on, an important issue. So our request is to be there for question answers at 2:30.
Sure.
And also some declarations. Only problem is that I don't know whether SN Rai from Orlando will be able to hold on with us, and Ramesh Singh also. Yeah, please.
Sandeep, what is the break time?
1:30 to 2:30.
2:30. 2:30 we'll be meeting again.
So,
Okay.
please announce this.
Yeah. So we announced the lunch break. We had lots of water. Now it's eating time, and we'll be back by 2:30. At 2:30, we'll have lots of question and answer session. So all the dignitaries, like even all the participants, you can ask as many questions as you want.
Followed by there are two lectures.
Dr. Sawant, why
Yes.
not you bring your lunch and you continue this? Okay. Otherwise, it becomes very, very difficult right now. Okay. I wanted to ask Dr. Jan some comments, but
Yes,
Dr. Jan is
Yes,
okay. I say okay. Thank you very much. I'm really sorry. I'm in California. It is 1:15. Okay. Dr. Jan, thank you very much. And I must compliment you for giving an overview of groundwater resources in India. And we have met at IIT Mandi when I had organized C2E2 Himalaya. So now you can recall me.
Yeah,
Okay.
yes, we had met.
Yes. So that was the wonderful lecture. Okay. And I'm
Thank you for the
very
compliment.
much. Yes, I'm very much aware the ways you do things. Okay. And I would like to invite you to write a review article, about the status, and I bring out Geomatics, Natural Hazards and Risk journal, which has the impact factor of 3.5, published by Taylor and Francis. Okay. And there is a charge, but I will waive that charge. Okay. For you. So that we can do. So the question is what you said, that the management is a problem in India, the water management.
Yes.
That is very difficult for me to accept that. Okay. But of course, over the years, we are using groundwater, and then the distribution of the rainfall and other thing is a real problem, not equally. Okay, there are so many agrometeorological region, which are suffering for the groundwater. So whatever you are saying is very easy to comment, but this is a very, very challenging job when you are saying that we can have inject groundwater, okay, and then there are so many problems, okay, in India about when you started about injecting. And of course, you were chairman of CGWP, and you wrote a paper with Senthil Kumar, okay, about the Bhuj earthquake in 2001 occurred, and which he published in 2021. For us, I'm still Indian. You see. Mentally, I'm there. Physically, I'm here. Okay. So getting data is really very difficult. And when you say injection, I know, and I can be, depending upon the data, you people injected water in Delhi, and you see, you triggered about 7 earthquake, is a small magnitude earthquake. So whatever your minister, this guy Shekhawat, okay, you people have spent crores of rupees in making this reservoir, a small reservoir along the Gomti River, Yamuna River. And within 24 hours, all the water drained out. Okay. And so, if you can provide me the water well level at Pala, that we can do some work about that. So these are the problem over the Indian Shield region. Injecting water or water draining is a real problem. Okay.
Can
Yes. Go ahead.
Supplement it here? See,
Yes.
basically the recharge in the Delhi area and the UT of Delhi has been confined to the floodplains of Yamuna River. Okay, the floodplain deposits not going beyond 60 meters of depth from the ground level, and the seismic activity which takes place and which has the epicenter is hundreds of meters below the earth, and basically this kind of saturation does not really impact the earthquake activity. It does not trigger.
I don't agree with you. Okay. I don't agree with you. Because I'm of the opinion that say Latur earthquake and other three also earthquake, even in Gujarat, one of some Saurashtra region earthquake, and a Palghar. Okay. So Palghar recently we published a paper. Okay. But Saurashtra and other Gujarat with the water injection, there is a triggering of earthquake. So we need data to prove that one. Okay. They, of course, when we met at IIT Mandi. Okay. At that time, I was raising questions, and you said, yes, we promised that we should share that data. Okay. But that data sharing is only on the paper. Okay. Not everybody.
I would clarify here that this data about the Pala well feed, the technical aspects, the aquifer dispersion, etc., it is available on the website of CGWP. If you like, you can have a look at it at the aquifer dispersion.
I know. Because not the latest data are available, and then the sampling rate should be different. And this is what, like in Nature India, and even the like Jaraman and other people, they have published some of my comments about that. Okay. So these are the very important. I'm aware of that. As I said, physically I'm sitting here. Mentally, I do some problems of India, whether it is the air quality problem, whether it is the water problem, and this is why I'm burning my.
No, agreed. But you see, what I am telling you is basically we have actually carried out the work, and the data is also published on the website. And if you like, I can make you the references available if you do not have them, so that you can try to convince yourself. And I am very much convinced. I have also worked across Europe and also in the African subcontinent. And then you see, we have undertaken a lot of such projects. There can be some, it is just coincidental, if I would say. Because unless the relationship between recharging to the aquifer and the movement of the subsurface formation has been established, the triggering of earthquake cannot be just related to recharging of water.
Sure. And we did some work long back in Arauli region, about the recharge in hard rock terrain, and that paper is more than 400 citations it has received. So anyways, I'm very happy that you gave an overview of the groundwater resources. And I invite you to write a review paper, because publishing something in India, and we would like to expose our capability, Indian capability worldwide. And this we should do that. So you can find my if you see the C2E2 Himalaya proceedings, you can find my email or Google. You will find that, and I will be happy to interact with you. Okay.
Okay, fine. And I'll write a review paper. There is no problem. You say I'll write a review paper also and maybe send it across.
Yeah, sure. Thank you very much. And I thank Dr. Sawant for organizing, and I'm very happy that I got a chance to speak. Thank you very much.
Thank you, Dr. Ramesh Singh. Thank you.
Okay, thank you.
Thank you for the compliment also.
Yeah, thank you very much.
May I add to this for a second?
Okay.
Yes, sir. Actually, I have downloaded. We are working in rainwater management from 8 years. So I'm just referring all the documents from CGWB website only. And recently for 2020 and 2020-21, also they have published data where I got the data of say uranium contamination also. So I think they are publishing the data on website. Just yeah, it's a bit tough to find because links are not easily available. We have to search it on Google and even on website. But it is available so I just agree to Jain sir on that issue.
You send me that link.
Sure, sir. Sure, sir.
Okay.
Sure, sir.
So thank you very much.
So, with all your permission, can we stop this session for the lunch? And we had lots of neck above. Now let's go for neck below.
Okay.
So we'll meet again at 2:30. Thank you very much, sir.
Okay, thank you.